And finally, here goes the second part of my solution. And we left off after creating the John object, including this huge calc tips method. Okay, now for Mark, this is all going to be very similar. And so I'm just going to go ahead and copy this entire object and then do some changes to it. So the name, of course, is not John, but Mark. And it's Mark Miller. Then this is $77, $475, okay. Then 110, and finally 45. So he only went to 4 restaurants. Then down here in the calc tips, all that we have to change is like these tipping rules. Okay, so let's see how Mark does it. So he likes to tip 20% when the bill is less than $100, 10% if it's between 100 and 300, and 25 if it's more than 300. So let's translate that into our code. So here it's 100. So less than 100, it's 20%, or actually less than 100. Okay, then if it's between 100 and 300, he gives 10% as a tip. And if it's even greater than 300, then he gives 25. So probably because he's at a very fancy restaurant and then he needs to give more tips, something like that. Okay, so that is the Mark object, and it's already done. So let's do the calculation here for Mark as well, and then log both John and Mark to the console. So let's check it out. And indeed, here we have our tips and our final values. All right. So this worked already. We now have the tipping completely implemented for both Mark and John. So let's take a look at what the next step is. And it is to create a function to calculate the average of a given array of tips. And then, of course, calculate the average for each family using that calculator, so that finally we can log to the console which of the families paid on average the highest tips. All right, so let's create that function. And I'm going to do it here after this object. So function calc average. And it's going to receive a tips array. Okay, so now I'm going to do what I told you as a hint. So I'm going to start with a variable called sum, which will start at 0. Okay, so in the beginning, of course, our sum is 0. And now what we have to do is to loop over the tips, and then in each iteration add the current element to the sum. So let's implement that. So for, and once more we start with a variable called I at 0, with I less than the tips.length, and then we increment I. So this is pretty standard. You're seeing at this point that it's basically always the same here, right? And so now what we do is that we say that the sum should be equal to the current sum plus the tips at the current position. Okay, makes sense? So let's say that we pass in an array of 2, 6, and 4. All right, so in the beginning, our sum will be 0, and then we will enter the loop. And so at this point, we have that the sum is 0 plus the current element, which is 2. And so 0 plus 2 will be 2. And so the new sum will be 2. So let's just write that down here. So we start up, of course, with 0. After that, we have 2. And so in the next iteration, we have 2 here as a sum. And then the current element of the loop is 6. So this one here. Right? So 6 plus 2 is then 8. Okay? And so 8 is assigned to that sum variables. Okay? Then in the next iteration, sum will be 8, and 8 plus the current element of the array, which is 4, will then finally be 12. Okay? And so that's it. So we went through the entire array and added all of these elements together, and in the end, we ended up with 12, which of course is the result of adding all of these 3 together. Okay? So that's just an example, just to demonstrate how this function works. Okay, and so in the end, all we have to do is to return the sum divided by the elements that are in the array. So tips.length. Okay, so for example, in the array that we had before, it had 3 elements, and so tips.length would be 3. And so the average would then be 12 divided by 3, which would be 4. Okay, so that's how you calculate averages. So we have now our objects, we have our calc average function, and so now let's do all the calculations. So we already calculated the tips here, then we log them to the console just to make sure that they are correct. Then we can also calculate the average. And what we're going to do here is to actually calculate the average and then store them inside of each of the objects. Okay, so I'm going to say John.average is calc average using John.tips. Okay, and why John.tips? Well, that's because this is the array in which all of the tips are stored, right? So that is the array that we defined here. So this.tips, okay? And so we pass that into the calc average function, which will then return the average, and we will store that into the average property on the John object. Now you may ask, well, why didn't we add this calc average here as a method to each of the objects? Well, we didn't do that because that would be duplicate code. So we would have to have the exact same code on both of these objects. And so we would basically repeat ourselves with the exact same code. And that's not good. Okay, so it's best to just leave it outside here as this function, then calculate it outside, and then only then basically add it to each of the objects. So we do it with John, and then we're also going to do it with Mark. All right, and so let's actually do this console log here after that, so that we also can see the newly added averages. All right, so let's try that now. And where is it? Yeah, here we go. So here's the average of the 3, or actually of the 4 paid tips. So we have these values here, and the average of them is 18. And in case of Mark, these are the 4 tips, and the average of that is 38, which is significantly higher, simply because of this huge tip here with $118. All right. So these are the calculations for the averages, and now all we have to do is to really do the console.log. So if John.average is larger than Mark.average, then we can say console.log, of course. So John.fullname. Now the escape, in order to escape the quotation here. So John's family pays higher tips with an average of, and now the average tip. Okay, and if it's the other way around, let's just copy it. It's Mark here, so Mark.average is greater than John.average. Well, then it's of course the other way around. So Mark and Mark here as well. All right, so that should be our final result. And indeed, Mark Miller's family pays higher tips with an average of $38. Okay, just to test this, let's decrease this one here from 110, or actually this one here. Let's decrease it from 475 to like $5. And so the average should then decrease. And so yeah, so now John Smith family pays the higher tips with an average of 18. All right, so that is the solution to this quite bigger and maybe a bit more difficult and confusing challenge. But I hope that you liked it and that you were able to at least do part of it. So I understand if you didn't do it all, okay? And so that's, again, no problem. You shouldn't feel bad about that. The most important part is that you try it here and that you put in the time to try to solve the challenge. So that's really all that matters at this point. And I'm serious here, okay? So that's really what matters most. Anyway, you're now done with the first JavaScript introduction. So congratulations on that for making it this far in the course. That's already a huge achievement. Now, some JavaScript courses stop at this point and consider that you know enough to write JavaScript on your own. But of course, that's very far from the truth. Now, don't get me wrong, you have already learned a lot by now, okay? But we are really just getting started with a lot of great content coming up over all of the next sections. And there's actually even one more video coming up in this section, which is just about the JavaScript versions. So make sure not to miss that one, because it's also important to know that kind of stuff. It's not about coding, but it's still important, okay? So I hope that you take a look at that right now. Now that you're familiar with the fundamentals of the JavaScript language, and before moving on, we need to quickly talk about JavaScript versions, okay? Now I could have probably talked about this right at the beginning of the course, but I just wanted to have you writing some code as fast as possible. Anyway, it's very important to talk about JavaScript versions because that's just something that every modern JavaScript developer should be aware of. And also because you will see these topics coming up in the developer community all the time. And so you want to be able to understand what's going on. So in order to do that, let's just very briefly talk about the history of JavaScript. So JavaScript was first released and called LiveScript in 1995, so a long time ago. But the name was then very quickly changed to JavaScript. And the reason for the change was just to attract developers of another language that was very popular at the time, and that's Java. So the Java in JavaScript was just for marketing reasons really, because the language itself has almost nothing to do with Java. Some beginners think that this is the case, but no, JavaScript and Java are actually two completely different languages. Now, 1 year later, the language was submitted to an organization called ECMA International in order to create a new standard. And so ECMAScript 1, or ES1, became the first version of the JavaScript language. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice. Now, fast forward to 2009, ES5 was released with a lot of new features. However, it took many years for browsers to implement all these changes. And finally, the much awaited new version ES6 was launched in June 2015. And it was the biggest update to the language ever with a ton of new features. And this was, or still is, a really big deal for JavaScript and for the whole developer community. Now you will also see ES6 being called ES 2015, which is actually the official name. But most people just call it ES6, and so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 is that in 2015 we changed to an annual release cycle. So a new version of the language is now released every year with just a few new features per year, instead of shipping a huge new version every couple of years. So this way it's much easier for everyone to keep up to date, okay? So it's much easier for us developers like this. And so in 2016, ES 2016 or ES7 was released, ES 2017 in 2017, and like this, it will continue into the future. So what does JavaScript look like today, and which version should and can we use? So first off, ES5 is of course fully supported in all browsers today, and so that's the one that is safe to be used. Now about the newer versions ES6, ES7 and ES8, as of mid-2018, they are all actually quite well supported in all modern browsers. But the problem with this is that we can't just assume that our users use these modern browsers, at least not all of them. And the old browsers will of course not understand the ES6 syntax at all, and neither the ES7 and ES8 and so on and so forth. And so these old browsers are a big problem for us. Now the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. And I'm going to teach you how to do that by the end of the course, okay? And if you want to stay up to date with what features are currently supported in which browser, you can just check out the ES6 compatibility table, and the link is on my resources page. Next up, there are the future versions of the language like ES9, ES10, and so on. And these future versions together are many times called ES Next. Now some features of these future versions are actually already implemented in some browsers, and so you could use them by transpiling and polyfilling your code today. But to be honest, I wouldn't really advise you to do so at this point, because I believe that ES6, ES7 and ES8 together are powerful enough to bring the JavaScript development experience to a whole new level already, as you will see a bit later in the course, alright? So in this course, we're going to start by using ES5 in the first part of the course, and then move to ES6 plus, so ES6, ES7 and ES8 in the second part of the course, okay? And so here's how that's going to work. So we already talked about the JavaScript fundamentals using ES5, and we will continue using ES5 to look behind the scenes of JavaScript, do some DOM manipulations, learn all about objects and functions, and code up a huge real project. From there, we will then start using ES6 with an overview of what's new in the language. Then we're going to talk about asynchronous JavaScript, modern development setups, and code an even bigger and cooler real-world app, all using ES6, ES7, and ES8. Alright? Now, some people don't understand why I even bother showing you ES5 in this course at all, and actually have criticized me for doing so. And so here are a few reasons which I hope will make sense to you. So I truly believe that in 2018 and even 2019, it's still a good idea to learn the fundamentals of JavaScript in ES5 and then move to newer JavaScript versions from there, simply due to the fact that you will always have to understand ES5 in the future. And that is because many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer, sometimes you will have to work on older code bases, which will most certainly be written in ES5 or even older. And all in all, I just believe that you will be a better developer if you start understanding how ES5 works and only then move up to ES6 or newer. Because ES6 has some abstractions like classes that kind of hide how the language actually works behind the scenes. Alright, so I hope that this makes a lot of sense to you. And so let's now move on right to the next section. Hello and welcome to the section about how JavaScript actually works behind the scenes. So now that you have a basic knowledge about the language, let's take your skills to the next level and take a look behind the scenes of JavaScript. And this is a part that many JavaScript courses out there simply skip or just mention very briefly. And that's actually really a problem, because this stuff is something that you really need to learn. Because if you truly understand how the language works, well, then you're going to be able to write better code, to debug your code, and to better understand other developers' code. And so in the end, everything that you're going to learn in this section will really make you a better JavaScript developer. Now, these lectures are a mix of theory lectures and coding examples. And so you'll actually immediately practice what you learn here. And if something feels a bit overwhelming, well, then don't worry, you can always rewatch the lecture or also come back to it later. So, are you ready? Then let's get started. So, in this first theoretical lecture, we will just very quickly see how the JavaScript code that we write is actually executed. So, JavaScript is always hosted in some environment, and that is most typically a browser, such as Google Chrome, Firefox, Safari, etc. And this is where JavaScript runs. There can also be other hosts, such as the Node.js web server, or even some applications that accept JavaScript code input. We will, however, always just focus on the browser in this course, which is exactly what we have been doing so far. So when we write our JavaScript code and actually want to run it, there's a lot of stuff happening behind the scenes. So what happens is that the host where JavaScript is hosted has some kind of JavaScript engine that takes our code and executes it. So in very simple terms, a JavaScript engine is a program that executes JavaScript code. There are many different engines out there, like Google's V8 engine that is used in Google Chrome, but there are others like Rhino, SpiderMonkey, JavaScript Core, and many more. Now, the first thing that happens inside the engine is that our code is parsed by a parser, which basically reads our code line by line and checks if the syntax of the code that we gave it is correct. So this means that the parser knows the JavaScript rules and how it has to be written in order to be correct, to be valid. And if we make some mistakes, it basically throws an error and stops the execution. If everything is correct though, then the parser produces a data structure known as the abstract syntax tree, which is then translated into machine code. So this code is no longer JavaScript code, but a code, or let's say a set of instructions, that can be executed directly by the computer's processor. And it's only when our code, already converted to machine code, actually runs and does its work. So it's not really important that you really memorize all of this. I just want you to get the basic idea of what actually happens once we choose to run our code. And there's actually way more going on behind the scenes, and different engines do things in a slightly different way. But this is absolutely enough for us to understand at this point. So let's now move on to the next lecture. The last lecture was a conceptual overview about what happens in the JavaScript engine once we run our code, how it's parsed and translated into machine code. Now let's focus on the order in which the code is run, and for that we need to talk about execution contexts. All JavaScript code needs to run in an environment, and these environments are called execution contexts. So you can imagine an execution context like a box or like a container, which stores variables and in which a piece of our code is evaluated and executed. We will go more in depth about this in the next slides. Now, the default execution context is always the global context. Remember that I said that an execution context is where a piece of code is executed. Well, in a global context, all the code that is not inside of any function is executed. And this is very important. So again, the global execution context is for variables and functions that are not inside of any function. Now, you can also think of an execution context as an object. Remember objects from the introductory lectures? So the global execution context is associated with the global object, which in case of the browser is the window object. So everything that we declare in the global context automatically gets attached to the window object in the browser. And it works like this. Declaring a variable called lastName or window.lastName is the exact same thing. It's like lastName is a property of the window object. And as we talked about in the intro lectures, properties are just variables attached to objects. So this makes sense, right? And I know this is a lot to absorb, so I really encourage you to take some notes about all these things to reference them later. And of course you can also watch these lectures again when you feel more confident with your coding. So remember, the global execution context is for code that is not inside of any function. But what about code that is in functions? It's actually very simple. Each time that we call a function, it gets its own brand new execution context. Let me show you that by an example. So this first declaration is not in any function. So we are in a global execution context here, as the red arrow down there shows on the right side. So this variable is stored in a global object. We will see how exactly that works in the next lecture. Next up, this function declaration is also in a global context. So we're still here in the same execution context. And the same about the second and the third function. And this is where the fun begins. Because here is where we call the very first function. And as I mentioned before, a new function gets its new execution context. And what happens is that this new context is put on top of the current context, forming the so-called execution stack. So for the duration of this first function call, the execution context for that function becomes the active context in which the code is executed. Okay, so let's get inside the first function with our arrow. So this a variable will now get stored in the execution context for this function, and not anymore in the global context. And now we call the second function, and I'm sure you can guess by now what will happen, right? So once again, a new execution context will be created and put on top of the execution stack. And here we go, this is now the active context. Okay, so now variable b is stored in this new execution context. And now we call the third function. And once more, a new execution context is created and put on top of the stack, as we already know. So now inside of the third function, we just have these two variable declaration and nothing more. So this function has now done all its work, and so we say that the function returns. So what happens to its execution context? It just gets removed from the top of the stack. Very simple. And then the context of the second function, which called the third function, is back to being the active context. And we go back to the second function. So this z variable gets stored in the currently active context, and after the function returns, the context is also pops off the stack. So back to the first function now, and here the same thing. The function is done, it returns, and so we exit it, and the execution context pops off the stack. And like this, we executed all three functions, created three execution contexts, and popped them off the stack when the functions returned. I hope that all of that made sense to you. Now, you may ask, how are all these execution contexts actually created? And why is this so important? And the answer is in the next lecture. So go watch that one right now. Okay, so in the last lecture, we have seen when a new execution context is created. But what about how exactly that happens? So let's talk about that right now. Let's start by creating a representation of an execution context so that we can have a bit more detail about how it actually works. First off, as I mentioned in the previous lecture, we can associate an execution context with an object, which is what we have here. And this object has three properties. The variable object, which will contain function arguments, inner variable declarations, as well as function declarations. The scope chain, which contains the current variable objects, as well as the variable objects of all its parents. And the this variable, that we have already seen in action in the introductory lecture about objects. Alright, so how is this execution context actually created? Let's start with what we already know. When a function is called, a new execution context is put on top of the execution stack. And this happens in two phases: the creation phase and the execution phase. In the creation phase, we first have the creation of the variable object, and we will talk about that in the next slide. Then the creation of the scope chain, and this is a huge topic for itself, so we'll talk about that in the next lecture. And lastly, the this variable is determined in set. So basically, the properties of the execution context object that we have here on the left side are defined. Then in the execution phase, the code in the function that generated the current execution context is run line by line, and all the variables are defined. If it's a global context, then it's a global code that is executed. So let's now look at the creation of the variable object in the creation phase. So this is what happens in the creation of the variable object. The argument object is created, which contains all the arguments that were passed into the function. The code is scanned for function declarations, and for each function, a property is created in the variable object pointing to that function. This means that all the functions will be stored inside the variable object, even before the code starts executing. And this is very important for you to know. And lastly, the code is scanned for variable declarations, and for each variable, a property is created in the variable object and set to undefined. And these last 2 points is what we commonly call hoisting. Functions and variables are hoisted in JavaScript, which means that they are available before the execution phase actually starts. They are hoisted in a different way though. The difference between functions and variables is that functions are actually already defined before the execution phase starts, while variables are set up to undefined and will only be defined in the execution phase. As you remember from the last slide, the execution phase comes just after the creation phase. Now, hoisting is something that confuses many new JavaScript developers, so it's really important that you understand it right now. That's why we're going to write some code in the next lecture so that we can see this in practice. So just to recap all of this once again, each execution context has an object which stores a lot of important data that the function will use while it's running. And this happens even before the code is executed. Alright, let's go to the next lecture to see hoisting in practice. So, hoisting may sound a bit confusing to you, but it's really not, believe me. So let me prove it to you by writing some code. So once again, I have some starter code for you, which I put here on my desktop. So let's just go to our text editor and open up the project. And in my case, it's brackets. And I have brackets and Google Chrome here side by side, such as we had before. So in case you're using brackets, just hit this button here and then hit open folder. And in my case, it's here on the desktop. So I'm just going to open this project and here we are. So in this project, I have once again our simple HTML file, which is this bare construction of the HTML file, just the structure. And this time I already have included the script, which is also here already. And I have also already set the stage here for this lecture. Okay, so I'm just going to use some very simple functions here because I just want you to focus on how everything works and not exactly on what the code is doing. Alright, so let's start by writing a simple function, and we can actually use the one we have been using before, so the calculate age function. And remember, we have been writing it like this. Calculate age and then year. And this time we don't even want to return anything. I'm just gonna console log the result to the console. So 2016 minus the year. Very simple, but it's enough for us. So this is how we've been doing it up until this point. So we first declared the function and then called the function. So I'm going to use calculate age and let's say 1990, which used to be John's birth date. And now I'm going to open up our file, our HTML file, and here we go. And the console, so I told you in the last section that we can do inspect to open the console. But we can also come here to the View menu in Google Chrome, Developer, and then the JavaScript console, which is the same as hitting this shortcut, so Alt-Command-J on a Mac and probably Alt-Control-J on a PC. Alright, and here we already have the result. Okay, so this is the way we have been doing things. But with what we learned in the last lecture, we can also do it the other way around, right? Let me show it to you. I'm going to delete it and use the function here before I actually declare it. Let's see how this works out. Calculate age, and let's now put 1965, for example. And if I now reload this, then this still works. Okay. And this is what I've been telling you about in the last lecture. So this is hoisting. So in the creation phase of the execution context, which is in this case the global execution context, the function declaration calculate age is stored in the variable object, and even before the code is executed, right? And this is why when we then enter the execution phase, the calculate age function is already available for us to use it. So we don't have to first declare the function and then use it, but we can also first use it like this and only later in our code declare it. Now remember another thing that I said in the last lecture, which was that this only works for function declarations, but there's also something called function expressions, right? So let's see how this works out with function expressions. So let's write another function as a function expression. And this is how we do it. So we declare a variable, and now we're going to reuse the function that calculates the years that we have left until retirement based on the year of birth. So I'm going to call it simply retirement. And then function and the parameter year. Okay, we just want to console log here the result. And the way we have been doing this is to make 65 minus the age. So it would be 65 minus the age, and the age is just 2016 minus the year, right? Okay. And we need the parentheses here because we want this part to be calculated first, and only after that we want then 65 minus this part of the operation. And remember, if we group something together with parentheses, it gets the maximum precedence in the operation precedence table, right? So this is the absolute priority. Okay, so let's now use this first like this. So retirement 1990, and hit reload, and here we go. So for someone who was born in 1990, he has 39 years left for retirement, right? So now let's try and see what happens when we do it like this. So the way we have done it up here. So I'm gonna go ahead and delete this and try to first call the function and only after that to write it in the code. So retirement, and let's try again 1965, and then let's use it. Okay, and now this time it does not work. So this is what we expected, right? And once again, the reason for that is because this function is not a function declaration, but a function expression. And hoisting with functions only works for function declarations, which is what we have here, right? Okay, great. So in order to make this work again, I'm just going to commit out it here, but I will leave it in the code so that you can have it for yourself and download this code at the end. Okay, so that is function hoisting. Now remember that hoisting also happens with variables, but in a different way. So let's see some examples about that. So here we have functions, and take away this space here. So here, variables. So let's once again create a variable here, and I will create an age variable. So age, and set it simply to 23. And just to check that everything works, let's console log this variable just to see what happens. Okay, 23, exactly as expected. Now, what happens if we use this variable before we actually declare it in our code? So let's see what happens in this case. Console log age. So again, we're trying here to use this variable before we declare it in our code. So I'm sure you know by now what's going to happen. So here we go. All right. So we have undefined, and that's exactly how hoisting works with variables. Because remember, in the creation phase of the variable object, what happens is that the code is scanned for variable declarations, and the variables are then set to undefined. So imagine that we wouldn't even have this variable declaration here. If we then attempted to use the variable, we wouldn't get undefined, but we would get exactly an error, because then we wouldn't have any definition and JavaScript would not even know this variable. But in this case, JavaScript knows that there will be an age variable. We simply don't have the value yet. And that's also the reason why it's defined exactly as undefined, because in one of the first lectures we saw that variables that don't have a value yet will always have the data type undefined. Okay, so let's now take this one step further and write a small function called foo, which doesn't accept anything. All we're going to do here is to create our own age variable right inside this function. And let's set this one to 65, for example, and then console.log age in here, then call the function like this, and then console log the age again. So what do you think is going to happen in this example? So let's find out. Okay, so these are the results of these two console logs here, right? So line 26 and 29, so 26 and 29. So why does this console log here print the age of 65, and then this console log here prints the age of 23? So it's actually pretty simple, and it's because this age variable here gets stored in the global execution context object, right? So in the variable object of the global execution context object. Sounds a bit confusing, right? But if you go through the last lectures again, then it will make a lot of sense. So again, this age variable is declared in this global execution context object. And then this foo function here gets its own execution context object, in which we can also store an age variable. And it can be the same name. It really doesn't matter, because these are two completely different variables. This variable age is defined in the variable object of the execution context object of the foo function, while this age variable is defined in the variable object of the global execution context object. So each one gets its own variable object. So we have two different variables, and so the results when we print them are different. And we can see that the hoisting works indeed also the same way. Console.log. So if we attempt to print the age before we declare it here, then we will have also undefined. So an undefined comes here from line 25, which is this. Okay, so I hope hoisting is a lot more clear to you now. And the most important use case for hoisting is not even variables, but it's the fact that we can use function declarations before we actually declare them in our code. And that's the biggest takeaway from hoisting, actually. So this is something very useful and something that confuses new JavaScript developers. So I hope that you understand it with these lectures. So you can take another look at the code or even rewatch some of the lectures that we've just seen. And then after that, once you're ready, then let's just move on to the next lecture. We talked about how execution contexts are created and how that is related to variable and function hoisting. That was the first step of the creation phase. So let's now talk about the second step, the creation of the scoping chain. So what does scoping even mean? Scoping basically answers the question, where can we access a certain variable or function? In JavaScript, each function creates a scope, which is a space or an environment in which the variables that it defines are accessible. In many other programming languages, a scope is also created by if blocks, for blocks, or while blocks, but not in JavaScript. So here in JavaScript, the only way that we have to create a new scope is to write a new function. And this is something very, very important in JavaScript. Also, in JavaScript we have lexical scoping. And lexical just means where something is written in the code. So it's about the position of something within our code. Lexical scoping means that a function that is lexically within another function, which means that it's written inside of another function, gets access to the scope of the outer function, also called the parent function. And with that, it also gets access to the variables and functions that the parent function defines. But let's look at an example to get a better idea of this. So here we have some more demo code. In blue, we have the global scope, which is a scope that is accessible from everywhere, from all functions. Like the global execution context, you can think of the global scope as the default scope. So in this scope, we have access to the variable a and also to the first function. In orange, we have the scope of the first function, which defines the variable b and the second function. And this is a local scope, not a global scope. And do you remember what I said about lexical scoping in the last slide? Thanks to lexical scope, this scope has also access to its parent scope and all the variables and function that it defines. And in this case, that's the global scope. And finally in green, the scope of the second function. In there we have a console.log statement which attempts to print the values of variables a, b, and c. Now, these variables are not defined in that function, only c. But as we already know, a scope has access to the scope of the function in which it sits lexically. So when running this code, the JavaScript engine will not find variable b in the current scope, right? So it just goes up and looks in the scope of its parent function and says, oh, here is b, so let's use that. And the same happens for variable a. It does not find it in the current scope, and also not in the parent scope, so it goes even more up, all the way to the global scope. And this is exactly called the scope chain. Only if the JavaScript engine does not find the variable anywhere, it throws an error and stops execution. Now, it's very important to note that this does not work backwards. For example, the global scope will never ever have access to the variables b or c, unless we return the values from the functions. So locally scoped variables are not visible to their parent scopes. And this is why I put that red arrow pointing upwards, because that's the only direction the scope chain works. Now, how does this actually work behind the scenes? Remember the execution context object that we have been talking about before? In the creation phase, each execution context object will get the exact scope chain, which is basically all the variable objects that an execution context has access to. Because remember, the variable object is what stores all the defined variables and functions. So in this example, in the second scope, we have access to the variable object of the second functions, of the first function, and the global variable object. So what do you think will happen with this code in practice? Let's go back to our text editor and find out. So I have this code already here in my starter code, which is the one that you will have available for download. So here's the exact same code that we had in the slide before. So how exactly do you think this is going to work? I'll give you a minute to think about it. Alright, so let's see the solution. Great, so the console log actually printed variable a, b, and c. So hey, hi, and hello, right? Hey, hi, and hello. So why does this work? So this works because, of course, the scoping chain. And in this case, thanks to the scoping chain, the second function has access to the variables of the first function and of the global scope. And that's because the second function is written inside of the first, which in turn is written inside of the global scope. And that's why we call it lexical scoping. So another extremely important concept and very much used in practice as well. Alright, so we have seen that the concepts of execution context, scope, and scope chain are very related. Now before moving on, I just want to make sure that you really understand how these are related and where the differences are. So we saw that the scope chain for each execution context is stored in the execution context object. But I just wanted to make very clear that the execution stack is different from the scope chain. So here we see another simple code example And we already know how the execution stack works, right? So the first function gets called, which then calls the second function, which in turn calls the third function. And for each of these calls, a new execution context is put on top of the execution stack. Now, for the scope chain, things are a bit different. We see that the global scope contains the a variable, as well as the first and third functions. Then the scope of the first function contains the second function. And this is how I like to represent it. Now let's remember that the execution stack is the order in which functions are called, but the scope chain is the order in which functions are written in the code, where they are lexically in our code. So the order in which functions are called does not determine the scope of the variables within these functions. What determines the scope of variables is where the functions are written. Since the third function is not in the scope of the second function, of course it cannot access variables b and c defined in the second and first functions. It can only access the global variable a, because the function is written in a global scope. So it's the execution contexts that store the scope chain of each function in the variable object, but they do not have an effect on the scope chain itself. This is important to understand. So what do you think will happen in this case? Let's go find out. Let's first analyze the code that we have here. So we have in a global scope the var a, which is defined as hello. We have the first function here, and we have the third function, all in the global scope or in the global execution context. And then inside of the first function, we have the b variable, we have the second function call, and the function declaration. And we already know that because of hoisting, we can call the function before it's written here, right? Okay, and then in the third function, we just define variable d and attempt to console log variable c. Alright, so I'll give you a minute to think about what's going to happen once I hit the refresh button here in order to run this script. Okay, so I'm going to do it. I'm going to push the button. Alright, and so we have an error which tells us that C is not defined. So two things here. The first thing is, why can the second function even call the third function? So this bug here came from line 73, right? Which means that someone or somewhere this function was called, which of course was here. So the third function was called from the second function. And this once again is possible because of scoping. The second function has access to the third function because of the scope chain, right? So the second function has access to the global scope out here, in which the third function also sits lexically. And so the second function has the ability to call the third function because of the scope chain. And there's nothing new here, right? And now the second thing is, why do we actually get this error saying that C is not defined, even though it was the second function who called the third function? So the second function is the function that defined the C variable and then called the third function, but still the third function cannot access variable C, which it is trying to print here, which as we see resulted in this error. So by now I'm sure that it's obvious to you that the third function cannot access variable C because the execution stack is different from the scope chain. And so to answer the question, who can access the C variable, the order in which the functions were called does not matter. All that matters is that the third function is in a different scope than the second function, and so it cannot access variable C. So which variables could the third function actually access? So try to figure that out by yourself. So did you get it? Okay, so it's variable a and d. So let's just test that. So I'm going to console log this one here and then do console.log a plus d. And if I run this now, then I have hello John. And hello is a and John is d. So these are the only variables that we have access to because they are in the scope chain for the third function. Great. This is really cool, right? You are already familiar with a lot of super important and advanced JavaScript concepts here and a lot of important theory. And I can absolutely guarantee you that you already know a lot more than a lot of JavaScript beginners. So this is amazing, right? There's only one thing that we have left in this section, and that is the this keyword. So let's go right to the next lecture where we are going to talk about that. See you there. So we have seen in this section that the creation phase of an execution context has two steps: creation phase and execution phase. So far, we have talked about the object variable creation as well as the scope chain creation, both part of the creation phase. I hope that you have followed along just fine and taken a lot of notes, so that we can now talk about the third and last step of the creation phase, which is determining and setting the value of the this variable or the this keyword. So the this variable is a variable that each and every execution context gets, and as we already know, it is stored in the execution context object. So where does the this variable or the this keyword point? In a regular function call, the this keyword simply points at the global object, which in case of the browser is the window object. And this is actually the default. Simple as that. In a method call, which as you remember is a function that is attached to an object, the this variable points to the object that is calling the method. And something very important about this is that the this keyword is not assigned a value until the function where it is defined is actually called. So again, even though it appears that the this variable refers to the object where it is defined, the this variable is technically only assigned a value as soon as an object calls a method. But armed with all the knowledge that you have gained in this section so far, this makes total sense, right? And that's because we know that the this keyword is attached to an execution context, which is only created as soon as a function is invoked, which also means called. So invoked and called are the same thing. Alright, so let's now check out some practical examples of this in the next lecture. After the theory about this keyword, now comes the practice. So let's start and simply log the this keyword for this global execution context. So all we have to do is console.log this. And what can we expect here? Alright. So all this means is that the this keyword in the global execution context is very simply the window object. And that makes sense, right? That's because the window object is the default object, as we learned in the last lecture. Okay, let's comment out this part of the code and let's write a simple function. And once again, we're going back to our calculate age function, because we already know that so well. Alright, so console.log 2016 minus the year. And what we also want here is to console log the this keyword once again. This. Alright, and when we call this function, what can we expect this time? Actually, we have to write the function call up here. So calculate age. I'm going to go with 1985. So let's refresh this and try to guess what we're going to see now. So we first have the result of 31, which comes from this log here, and then the this variable is once again the window object. So does this make any sense to you? I hope so, because this is a regular function call and not a method. As we learned in the last lecture, in a regular function call, the this keyword always points to the window object. And it actually makes sense, because the object that this function is attached to is the global object. And it actually makes sense, because the object that this function is attached to is the global object. So it has to be the this variable here as well. Okay, so not a method, a regular function call. So the this variable is the global object. So let's move on to an object here. And we'll go back to our old John object. So name John. And here's not a semicolon, but a normal comma. Then year of birth is 1990. And let's now add a method here. And it will be our calculate age method once again. So calculate age. And once again, this is a little bit different than what we had before, right? Because this is like a function expression and not a function declaration. So in here, we can also console log this keyword. But first of all, we have to perform the method call. And that's as simple as this. So we use John and then we use to calculate age method on it. So what's going to happen now, and let me actually comment out this part of the code. Alright. So the this variable now is the John object, and it makes absolute sense, right? Because as we know, the this keyword refers to the object that called the method. And in this case, it was the John object. So of course, it has to be the this variable. And we actually already saw this in action before in the introductory lecture about objects, but at the time we didn't really understand it, but now it makes total sense why the this keyword refers to the John object, right? And now it also makes sense why we can then use this to calculate John's age. So console log this dot year of birth, right? So let's run this again. Sorry. And then we have final result. No, of course not, because it's of course 2016 minus this. All right, here we go. Now let's take this even a bit further here. And what we're going to do is to add a function inside of the calculate age function or method. So I'm simply going to call it inner function, okay? So this function will not really do anything. I just want to console log the this keyword in here as well. All right, and then we can call it, of course, inner function, and just like this, because it doesn't have any parameters. So now when we call the calculate age method down here, not only will these two console logs here happen, right? But also this function will be declared and then called, and therefore the this keyword will be logged as well. And now try to guess what the this keyword is going to be like. All right. So once again, the this keyword in here is the John object as expected. Then the outcome is of course 26 as we had before. But now comes something that looks rather strange, right? And that's the fact that the this keyword in this inner function here is now back to being the window. And this is a bit counterintuitive, right? And in fact, some people in the JavaScript community agree with this and others don't agree. Some people think that the this keyword in here should still be the object, this is the John object, right? But to me, actually, it makes sense that it's not, because it's simply the rule. And the rule is that when a regular function call happens, then the default object is the window object. At least that's how it happens in the browser. So once again, this is not a method, because the method is calculate age, so it's a method of the John object. But this function here, although it's written inside of a method, it's still a regular function. So when we call it, the this keyword will no longer point to the John object, but instead point to the window object. Okay, and this is something very important to keep in mind for the future and also for a future project. And now that this is really crystal clear, let's now complicate things a little bit more. So remember how I said that the this variable is only assigned a value as soon as an object calls a method? So I said this was important, so let's now see an example. And for that, I'm going to create another object, which will be called Mike. Var Mike will be another object, and this name will now be Mike, of course, the year of birth can be something like 1984. All right. Now imagine that we want to calculate the age of Mike. So one thing that we could do is, of course, to go ahead and copy this calculate method here and paste it here in the Mike object. But we could be really smart and instead do something that's actually a very common practice in JavaScript and that we will also use more in the future, and that's something called method borrowing. So we are going to borrow John's method to use it on Mike. And how are we going to do it? It's very simple. We just say that we want Mike.calculateAge to be John.calculateAge. Simple, right? So you see that in this case we don't have the parentheses, because these parentheses are for calling a function. And now we simply treat the function here as a variable. And so we can say that we want the Mike.calculateAge function to be the exact same as John.calculateAge function, which is this one here, right? Alright, so if we now go ahead and use a function calculateAge, because now I want to really call it, so I use the parentheses. So now I'm going to go ahead and call the function. But first I will actually make it a bit simpler. So I don't want this code here anymore to get in my way. So I'm now going to call it, and what are we going to see? Alright, so from the John calculate age call here comes the John object and the 26 age of John. So exactly what we had before. But when we now call the calculate age method for Mike, which we had borrowed, then the object becomes the Mike object, and now we have Mike's age here. So this is truly amazing, right? And this proves what I said in the beginning, which is that the this variable is only assigned a value when the object calls the method. So if it wouldn't be like this, then this variable here would always be John, right? Because it's in fact attached to the John object. But when we now call the same method from the Mike object, then the this variable becomes the Mike object. So again, the this keyword only becomes something as soon as the method gets called. And this is something really important once again. Okay, so I hope that this is really crystal clear now. And with this, we reach the end of our theoretical lectures. And for me, it's really good to see that you're still with me after all of these more theoretical lectures. And believe me that these lectures were really worth it, and they will absolutely make you a better developer over time. And even if you don't understand it now, I'm sure that you will eventually. And so from now on, we can build on what we've learned so far, and we can now focus even more on coding. So let's continue doing that right now. See you in the next lecture. This section is about DOM manipulation with JavaScript. So up until this point, we have only talked about the language itself, but never about how we can actually use JavaScript in a browser to make it interact with a web page. And that's why in this section, we're going to build our very first small project together. And this project is a very simple but fun game that we can play in our browser. So it's basically just an HTML web page that is going to interact with the JavaScript code that we'll be writing. So you will learn a ton of new stuff, and of course you will also use some of the concepts that you've learned so far. So let's go have some fun with this project now. So in this section, we are going to make JavaScript interact with a web page for the first time. And the technical term for that is doing DOM manipulation. So in order to do that, we need to first know what the DOM and DOM manipulation actually is. So DOM stands for Document Object Model. Now, the DOM is a structured representation of an HTML document that can be used to connect web pages to scripts or programming languages such as JavaScript. Imagine a very simple web page like the one we see here on the right side. We can say that each HTML element can be represented by a box like this, right? Now, the DOM is a fully object-oriented representation. So for each of these boxes, there is an object in the DOM that we can access and interact with, right from our JavaScript code. But before moving on, I just want to make crystal clear that JavaScript and the DOM are two different things. So what we have been doing so far was to just use the JavaScript language without any interaction with any web page. All we did was just to print some stuff to the console. But now we're going to use special JavaScript methods that allow us to interact and manipulate, which means change, the DOM, and therefore the web page. And since I said methods, that means that they are functions attached to some object, right? And that object is the document object. So this is the object that gives us access to the DOM. Okay, once again, the HTML web page content is stored in the DOM, which can then be accessed and manipulated via JavaScript. And that is exactly what we're going to do in the project in this section. In case that you have no idea what HTML and CSS are, you're in the right place. Because in this lecture, I'm going to very quickly go over the most important parts of HTML and CSS, just by looking at the project that we will be working on in this section. So if you're already familiar with HTML and CSS, then please feel free to mark this lecture as completed and then move on straight to the next one. This is the starter code of the project that we will be working on in this section. And this here is the HTML document. Alright, so an HTML document is what always holds the content of our web pages. In HTML, we have elements which are composed of ending tags, content, and closing tags in most of the cases. We then write these elements into one another and like this create a nested structure. And there are different elements for different things, such as links, paragraphs, images, sections, etc. For example, the div tag here has this opening tag, this closing tag, and this content here in between. And in this case, the content itself are even more HTML elements. But eventually some of these elements have some plain text content here. For example, here, or here, or here. Okay, so HTML elements can also have attributes, which are these. So this is the class attribute, the ID attribute, or for example, the source or alt attributes. And there are a lot of different attributes. Now, probably the most used one is actually the class attribute, which is this one here. And it allows us to give a certain element a name. And IDs, which we have for example here, also allow us to give elements a name. But the difference is that an ID has to be unique, but a class name can be used over and over again throughout the pages. For example, we have player name here and then down here again, but we have, for example, the ID name 0 only here because down here it's called name 1. Alright, so these are elements and attributes. Now about the structure of an HTML document, it is always divided into two parts, which are the header and the body. So the body is what we just looked at, and it contains the visible content of a web page. So it's basically everything that's here enclosed into these body tags. So that's it for the body. Now the header is what contains additional information about a web page, such as the title here or even some page keywords. And we can also do other things here. For example, in here we import into our code a custom font from Google Fonts and also an icon font, which will give us some nice icons that we can use to make our interface look nicer. And then here in the next line, but also still in the head of the HTML document, we connect our HTML file to a CSS style sheet, which brings me to CSS. So let us open our external CSS file, which is this one here. Okay, so if HTML is the content of the web page, then CSS is the presentation. And here in the CSS, we simply write rules to style our web page. So we have all these rules here. So here and all the way. So all this file is filled with CSS rules. And the way we connect the HTML with the CSS is by using usually class names. We can also use IDs or other selectors, but the most common one is the class selector. So this is the class name that we specify in the HTML. So let's go look at that. So player name, and that is right here. So the rule that we just saw here in the CSS styles all the elements which have the class of player name. And this here is the class selector. And if we go up here, we see another selector, which, for example, we have this one here. And this is called a type selector because it selects all elements with the type of body. So it simply selects the body of our web page. And we also have the universal selector, which simply selects all of the elements on the web page and applies these styles to all of them. Okay, so I think that is actually all I had to tell you. I hope that you got a small idea about HTML and CSS now. This should absolutely be enough to allow you to follow the next lectures, where we are going to need some of these concepts. If you want a full deep dive training into HTML and CSS, then you can of course try out my other course, which is called Build Responsive Real-World Websites with HTML5 and CSS3. Let's finally set up our project and take a look at the game that we will code, as well as the rules of that game that we will need to implement in order to make it work. So I have the starter code here on my desktop once again. So this code here that is available for download. So I'm gonna go to my text editor now and open up that project. And by now you already know how it works, right? So I go to my desktop and then hit open. And this text editor, so brackets, creates a new working project for me. Okay, so this time the starter project includes a little bit more than just a bare bones HTML structure. So this time we have a real user interface that I coded for this game here in HTML, as well as the CSS code for this project. And you can of course take a deep look at it if you want to know exactly how I coded that up. But on this project I want to focus fully on JavaScript and not how the HTML and CSS works in the background. Okay, so let's now take a look at the interface that I coded for this. And now as you see, I have the text editor here in full screen because now I need all the screen size that I can get. And I have the interface here on this side. So this is a beautiful interface that I created for our small little game, which is this one. So we have 2 players on left side and right side, and the goal of the game is to get to 100 points first. So I want to actually first take a look at the rules with you before I show it to you in action. So let's go back and open our JavaScript file, which is this one. And once again, I already connected it for you. So down here we have the script where we include the app.js file. Okay, so this is the file which is empty, except this comment here, which includes the game rules. So as I mentioned, there are 2 players and the game is played in rounds. And in each turn, a player rolls a dice as many times as he wishes, and each result gets added to his round score. But if the player rolls a 1, then all his round score gets lost, and after that, then it's the next player's turn. But in order to avoid that, the player can choose to hold, which means that his round score gets added to his global score. And after that, it's again the next player's turn. And the first player to then reach 100 points on the global score wins the game. So let's now see the game in action very quickly. So player 1 starts the game, and I'm going to start roll the dice. Alright, so I rolled a 4. So down here on my round score, I now have a 4. And I'm going to choose to hold, and then the 4 points get transferred to my global score, which we have up here in this big size. And now it's plays 2 turn, which we can see by this gray background and here this red dot. And I'm going to roll a dice as well, and now I have 5. And I'm going to choose to roll again, and I rolled a 3. So 3 plus the 5 that I had before is now 8. And I'm going to choose hold as well. So now player 2 here is in the lead. Alright, player 1 once again. Now I'm going to roll the dice all the way until I roll a 1, which, as you know, will make me lose all of the score. So just to show you what happens. Alright, so I apparently rolled a 1 and lost all of my round score and nothing got added here, right? So I will now play with this one here, choose hold, and let's play this game until the end. And we have a winner here. Player 1 won the game. Alright, so this is how this game works. Super fun, right? I think it's really cool for a first real project. So let's go straight to the next lecture and start coding this. Now it's time to finally start coding up our game and put into practice what we learned so far about the DOM. But one more thing before that. From now on, in all the coding lectures of a project where we learn multiple new things and concepts in one single lecture, I will give you a quick summary like this one, so that you can later reference what we did in each lecture. And this will be very useful in case that you need to ever come back to these lectures later. And that being said, in this lecture we are going to learn how to create our fundamental game variables, how to generate a random number, how to manipulate the DOM, and how to read from the DOM. So here we are back in our JavaScript file. Let's create some empty space here. Okay. So one thing that I didn't mention yet so far is that this game is actually called the pig game. So if you try to Google this, you will then also find these exact same rules and also some variations that we'll maybe talk about later. Okay, but let's start. So we need to first create a couple of variables to keep track of the most important things happening in our game. And probably the most important thing of all is the score for each player. Now I could go ahead and create a variable for each player like this, score 1, set it to 0 and score 2 and set it to 0 as well. But we want to keep things clean, and so I only want one variable. So how are we going to do this? We are going to use an array. So I'm just going to call this one scores and set both scores to 0 in the beginning, right? Okay, and I also want a variable for the round score. And this only needs to be one value because we only have one score at a time, one round score at a time, right? So round score equals 0. Now let's keep our code a little bit more organized. So instead of doing it this way, I'm actually going to declare all of these variables up here like this. So var scores and round scores, and then remove the var from here. Okay, just like this. So these are the variables for the scores. What I also need is a variable which will tell me which is the current active player, right? And this variable is to keep track of the player that is currently playing. So let me declare it here actually. So active player, and then I will set it to 0. So 0 will be the first player and 1 will be the second player. And I'm doing it this way because later we will use this variable to read the scores out of this array. And since this array is 0 based, we need the 0 for the first element here and then the 1 to read or write the second element. Okay, so these are the basic variables that we need for now. We will probably add some later, but it's enough for now. So let's now think about the dice. So in order to create the dice, we need to calculate a random number, right? So let's call it dice. And of course, as you know, I need to declare it here. So dice. And now I'm going to use the math object. And the math object is a JavaScript built-in object that has a lot of properties and methods for mathematical constants and functions that can be very useful for us to do this kind of calculations. And the random one is one of them. But let me actually show it to you in the console. So I'm just going to set this to some value and then come back later here. So to open the console, I'm opening Google Chrome, and actually I will simply open my file here. So the index.html file, which will then open our app and our user interface. Okay, so here we have it. So this is the default. So when we open this, we actually already have some pre-filled numbers here, as we can see in our HTML here. So you see here 43 is the score for player 0 and 72 is the score for player 1. Okay, but back to the console. I'll hit inspect and then head over to the console. Now let's start by using the math object. So math dot, and now there's a very handy method called random, which basically gives me a random number between 0 and 1. So if I run this again, it will give me another number, and another, and another, and another. So these are all different, right? Now I don't want a number between 0 and 1, right? I want a number between 1 and 6. So the first thing I'm going to do is to multiply this value by 6. So let's clear the console. So if I multiply this by 6, then we will have a number between 0 and 5, right? So 0.9, 4.6. Okay, but you see the problem here, because these are decimals. But we don't want decimals. What we want is an integer, right? So there's another very handy function in the math object, which is called floor. And the floor method simply removes the decimal part of a number. So let's test it. For example, 4.6 will become 4. Okay, so what we should do now is to use this with the math random times 6, right? So I'm going to use math.floor of math.random times 6, which is what we had before. And now this will give me a random number between 0 and 5. So 0, 3, 1, 2, 2, 1, 4, 4, 3. Okay, so as I said, this will be a number between 0 and 5, but we want from 1 to 6, right? So all we need to do now to make this perfect is to simply add 1. Okay. So now this will give me a nice number between 1 and 6. So let's now copy this, and I did this in the console so I could show you the effects of the random number generator. But now we want this in our code. So I'm coming back here and paste it here. So now our dice variable takes this random number each time that it's defined. So let's now console log this dice. Can close up the console. No, actually we can't, of course. Alright, so 6. And if we now reload this, then this time we have 5, 3, 6. So as you see, this is a random number now. Okay, so this was the first thing. Now the next thing is to actually do some DOM manipulation. So let's do that. So as I said in the theoretical lecture, the object that will give us access to the DOM is the document object, right? So let's use that. Document. Now there are a couple of methods that we can use to select elements from our web page. And the most useful one, and the one that I use all the time, is query selector. So again, I need to use the dot and then query selector. Alright, and how does query selector work? So query selector is really to use because it lets us select stuff exactly the way we do it in CSS. The only difference is that it only selects the first element that it finds, but there's a solution for that I will show you later. But for now, what you need to know is that it's really easy to select things with query selector, because if we know how to select stuff in CSS, then we can do it with query selector. So let's now select something from our page. And what I want to do is to select this text here and put the value of our dice right here, so that we don't have to open up the console anymore to see our value, but instead we can print it right here. So in our HTML, we see that this 43 is right here. So in order to select this, we need to use this ID score 0. And if we wanted to do the same thing for the other player, which is player 1, then we'd have to use score 1. But now all we need is score 0 here. So we need a string here, and then, as you know from CSS, in order to select IDs, we use the hash symbol and then simply score 0. And that's it. So now we have selected the element. Now if we want to change the text in this element, then we need another method, which is the text content method. So text content. And now we can simply say that this should be the dice, which is the variable that we define up here. So I can now remove this and check out our web page. So let's now really close the console and reload this. And now actually the dice appeared here, not where I wanted it, not down here. So let's reload this. Okay, so the value appears here, but it's no problem, right? So 6, 6, and 6 again, and now 2, and 5. Alright, so this is actually working. Not the way we intended to, but it's still working. Because we actually had to select current 0, not score 0, because score is the global score and not the round score. So let's put it in the current. Great. Now right in the beginning we defined a variable called active player, right? So this was to keep track of the player that is currently playing, and we're going to use this variable to read and store values here, but also this number here is used in our HTML. For example here, so player 0 for score 0 and current 0. And down here we have 1, 1, 1. So we can also use the current player variable to select stuff, right? All we need to do is to build our string here. So I can do current and then plus active player, right? because of type coercion, JavaScript will then convert all of this to current 0 if this is 0. But if it's 1, then it will be current 1, which is exactly what we had before. But now it's more dynamic because then we only have to write it once. So when we change the active player, then the score will be printed in the other label. So let's test this. So let's set this to 1 and let's see how this works. Okay, so now we have it here. Let's dice again, roll the dice again. So 6, 1, and 2, and so on. Okay, cool. So what we did was to simply change the content of an HTML element here. Now to change the content of a selection, there are actually two ways. So we used the first one here, which is text content, but there are two ways. And the text content that we have here can only set plain text, so no HTML. But if we want to put some HTML also in the selected element, then we have to use the inner HTML method instead of the text content. So let's see how that could work. So let me comment this out and write it again. So document.querySelector, and I want again the current one. What I'm going to do is like this, active player. And now instead of text content, I'm going to use inner HTML. And now I will write some HTML, which of course needs to be a string once again. Because if I would just write it like this without being a string, then the JavaScript parser would think that this is some JavaScript code, which of course, if we have something like this, then this is of course not JavaScript, and we would have an error. So every time we want to write some HTML here in our code, it needs to be a string. So let's now use the EM element here around the dice value, which will then emphasize it. So basically it will be an italic text. So dice, and then close this element. So let's see what happens now. Alright, so now we have this italic text here. So it is slightly to the side, right? This number 4. 4, 6, and so on, so on. Okay, so what would happen if we would simply do this with the text content method that we used before? Text content. So let's reload this once again. And then we would have all this text here, because once again with this method we can only set text and not HTML. So then it would interpret all of this HTML code as plain text. So this is not what we want. So this was just to illustrate you. Set it back to inner HTML, and I will comment it here, because what we want really is this. Okay, so we just did our very first DOM manipulation, which means that we use this query selector method here to manipulate, to change values in elements of our web page. Now we can also use this method to actually only read the elements from our web page and then store them in some variable, for example. So let's now do that. I will create some space. So let's simply create like a random variable, and this is just to show you var x, and once again document.querySelector, and let's now use something else. For example, the global score here, right, which is 43. So again, this is an ID, so I use the ID selector that we already know from CSS, and then score 1. And this time I'm just going to write it out like this, or actually score 0, because this is just to show you how we could use a query selector the other way. Okay, and now the text content. So this time we don't set it to equal anything, because again, this is just to read the value or the content of the element with this ID, score 0, and then store it here into variable x. So let's quickly console.log x so that we can see that this also works this way around. So I am going to hit Command Alt I, to bring up the console. And let's now reload the page. And here we are. So 43, which is the value that we read from here, stored in our x variable and then printed right here to the console. So this works not only for setting, but also for reading. And in this case, when we do it like this, we say that it's a setter because we set a value, and in this case, we say it's a getter because we get a value. Alright, and now there's only one more thing that I want to show you in this lecture, which is that we can also use the query selector to change the CSS of some element. So let's now use the document object once again, query selector, which will return a selection, and I'm going to go back to the web page. What we want to do now is to hide this dice here right in the beginning. So when we open up the game, we don't want to see this dice with this random number here, right? So in CSS, we do that by setting the display property to none, right? So let's do that. So in our HTML, where do we have the dice? And it's right here. So it's this image here with the dice class. So this time we have not an ID, but a class. And to select the class, it is the dot selector. So all we need to do is dot dice. Alright, so this gives us our selection. And now instead of changing or getting the content, we want to change the style. So we first need to use the style method and then the CSS property that we want to change. And it's as simple as that. So as I said, we want to change the display property and set it to none. So we write display and then set it to none. And that's really it. So if you remember what CSS looks like, let's take a look. So this here is the property and this is the value. And in JavaScript what we do is we use first the style method, and then this is the CSS property, and this is the CSS value that we attribute to this property. So let's see if this actually works by reloading this. And yeah, here we go. So our dice is now gone. If we now inspect this page, let's actually do this and go here to our dice, then we can see that with JavaScript what we did was to basically change the inline CSS and set the display to none here. So we also can see it in your HTML. So we now have the style attribute here and the display was set to none. Okay, and that's it for this lecture. Now the next step would be to actually display the value each time that we click our nice button here, right? Because right now nothing really happens. But what we want is to show our dice here and to show our score. And right now nothing of that happens. So let's do that in the next lecture. Before we move on with coding the roll the dice button, let's talk about another important topic that is closely related with the DOM and DOM manipulation, and that's events. Events are like notifications that are sent to notify our code that something happened on the web page. And events are triggered by things like clicking a button, resizing a window, scrolling down, or even pressing a key. We can use event listeners to code responses to all these events, like opening a pop-up window, showing animations, and so on and so forth. So an event listener is just a function that basically sits there and waits for a specific event to happen. And how is that event then processed? Well, first we need to remember about the execution stack. And that's because the rule is that an event can only be processed or handled as soon as the execution stack is empty, which means that all the functions have returned. So in here, we currently have two execution contexts on the stack. So these have to return first. Just like this. Okay, so besides the execution stack, we also have something called the message queue in the JavaScript engine. This is where all the events that happen in the browser are put. and they sit there waiting to be processed, which, as I said, only happens once the execution stack is empty. And that is the case now here in our example. So the next event in the line will now get processed. Remember from the last slide that we can have something called an event listener, which is a function that reacts to an event. So that event listener is now called. And since it's a function, it gets its own execution context, which is then put on top of the stack and becomes the active execution context. So this is how events are processed and how event listeners work. So let's now use what we just learned in practice in the rest of the lecture. In this lecture, you will learn how to set up an event handler, what a callback function is, and also what an anonymous function is. You will also learn another way to select elements by IDs and how to change the image in the HTML image element. Alright, so let's now set up our event handler. And the first step is to select the element in which the event will happen. So in this case, it will be the button where we will roll the dice. So this button here, right? So let's go into our HTML file and find out how this one is called. And it's this one here, so roll dice, and the class for this one is the button roll button, right? So btn roll. Okay. Once again, we need to select this element. So by now you've seen that it always works like this. So we first select something using query selector, so like this, and then after that we do something with that selection that the query selector method returns. So once again, we use the document.query selector, and now we use the button roll. Alright, so we have our selection, and now we can add the event listener, which is as simple as this: add, and here we already have it, so add event listener. And here we have two arguments. The first one is the event type, which in our case is simply click. So there are a lot of events, as I told you, and this one is the click event, but there are a lot of them. And so we have a nice handy reference, which I already have here. So once again, this is on the MDN webpage, where I also showed you the operator precedence table. So let's search for the one that we use, so click. So this is the click event, and it's one of the mouse events, but there are lots of them. So mouse enter, mouse move, mouse over, mouse down, mouse up, and all of these events. Then we have drag and drop events, we have these media events, and we also have keyword events up here, clipboard events, so when we copy or cut something. And as you see, lots of events are possible. For example, when the page unloads or when our page loads, and all these kinds of events. So when you need something else beside click or beside anything that we will learn in this course, you can just come to this reference here and use it from there. Okay, so the first argument to the add event listener is the type of event. Now the second part is the function that will be called as soon as the event happens. So for now I will leave this empty. So imagine that we would have a function that we want to call when we click on the button. So I'm just going to call it function button with no parameters and just like this. Do something here. Okay. So remember, if we wanted to call this function, we would do it like this: button and then the call function operator, which is this one, right? So in order to call a function, we always use these parentheses. Now, if we want to use this function as our function that is called here as soon as we click on the button, then we would simply do it like this, just the name of the function without the parenthesis operator, because we don't want to call it right here. we want the event listener to call the function for us. And this button function is then called the callback function. And that's because it's a function that is not called by us, but by another function. So this is what a callback function is, a function that we pass into another function as an argument, and this function, in this case the event listener method, will then call that function for us. Alright, but what if we didn't want to have an external function that gets called by the event listener? We could simply add the function right here. So instead of having this function name here, we could write our function right here. And that would be an anonymous function. So another concept here. So an anonymous function is simply a function that doesn't have a name, so it cannot be reused. We can just write function here, like this, then the usual way with our curly brackets, open it, and then write our function code right here, such as we did before. So once again, we can do something here. Again, if we don't want this function here on the outside, we can very simple write our function right here into this event listener method. And we do that by writing an anonymous function, which is a function that doesn't have a name and that we therefore cannot use outside of this context here. So we cannot call this function button to use it then later in another place. So this function can then only be used here. But in this case, that's what we want, because we don't want to use the button function anywhere else. All we need this to happen is when someone clicks on the button. So an anonymous function is the perfect solution here in this case. And this is usually the way that we handle this. Now, what happens as soon as someone clicks the button? So let's use comments here to define our next steps that we have to take here. So first, we need a random number. Right, and we already did that. So let's already copy this here into our function. So we only need this number as soon as someone hits the button, right? We don't need this right after our application loads. We only need this as soon as someone clicks. Okay, and after that, what we need then is to display the result, right? And after that, what we want to do then is to update the round score, but only if the rolled number was not a 1. Because remember, if we roll a 1, then we lose our current score and it's the next player's turn. Alright, so here our dice variable, I will actually only declare the variable here in this function because I don't need it from the outside. So remember, due to the scoping chain, here in the outside scope, we will only have access to the variables that are in the scope and not access to the variables that are in the scope of another function. So I will remove it from here. And now this function is the only one that has access to the dice variable. But the other way around, from this function here, we have access to the outer scope, right? So in this function, we will have access to the scores, the round score, and active player variables. And this is very important. So once again, the scoping chain is something very important and really important also to understand. Okay, so we have our random number. Now we also need to display the correct dice number, right? So we first have to make it visible again because we hid it up here. So we set the display style to none. So the first thing is to bring the style back to block. So in CSS, when we want to display something as a block, we simply use the display property and set it to block. So document.query selector, and we see from up there that it's just the class dice. And then .style and .display and set it to block. Alright, but we also need to set the correct number, right? And this is why these images, so 1, 2, 3, 4, 5, 6, have the number here in their name. So this is a trick that I used so that now it's very simple for us to display the correct name. All we need is to write this name and then add the number of the dice value that was rolled, right? So if we roll a 1, then we need the dice 1 image. And the same thing for the other numbers. So how do we do that? Once again, we will select our dice, but instead of always doing the same selection over and over again, which is a process that takes up some time, so it's not perfect if we do all the same operation all the time. So what I can do instead is to create a variable where I store the selection and then use this variable whenever I need it. So I will create a new variable, and once again, we only need it in this scope and not in the outside. So I only declare it here in this function. And I will call it dice DOM, simply because it's the DOM object for this dice. And so now I'm going to copy this part because this is effectively our selection, right? So query selector of the dice is what we select. And now all we have to do is to use the variable that we just created. So we can make it like this. And now down here we can use it again. And we don't have to make the selection over and over again. Now how do we change the image of an image element? So we see here that the image is an img element and the source is what defines which image is displayed. So it's very simple to change this source attribute, because in JavaScript all we have to do is exactly that, source, src. And so now we use this trick that I told you about. We just write this part of the name, so dice and then the number that was rolled. So dice plus, so actually dice, right? Because this variable here, which has the number from 1 to 6, which the dice rolls. And now we just need to add the final .png plus .png. And that's it. So it's now time to test this again. So let's reload this and then roll the dice. And now this is not really working. So let's check out the console. And the error that we get is that the dice is not defined in line 20. So let's check that one out. And yes, indeed. So here we use the dice, but it's not defined because it's only defined down here. But it's not a problem because these lines here in the beginning, they were only to show you some things which I don't want anymore here anyway, because we are just going to use these inside of a function or even of another function. So these one were just to test some things. So I will just cut them here and put them down here in case I need them later. And I will need them, of course. So the only thing that matters for our application here really is these variables, then hide the dice, and then our event listener function here. So let me close this, reload, and now it's going to work. Alright, so 5, 6, 6, 3, and so on. So now this works. Really cool, right? So our game is starting to look nice, right? What I want to do now is to actually set these values here to 0. And I'm not going to do that in the HTML code, but right in the JavaScript. So let's do that. So we come here to our HTML to see how these are called. And these are the score 0, current 0, and score 1 and current 1 IDs. So these are IDs. Now we could of course use the document.querySelector just fine, such as we did before, but I want to show you another method now, which is the document.getElementById instead of querySelector. So this only works for IDs, but is faster than querySelector. So sometimes when we have IDs, instead of just using querySelector all the time, we use getElementById for IDs. So let's do that. So document.getElementById. And now we don't use the CSS style, so we don't use the hash symbol such as we did if we would use the query selector, but all we do is to put the name in here. So it's score 0 and then text content, as you already know, right? And set it to the string of 0. And I will now duplicate this line, and we'll do the same for the score 1. And I will actually duplicate it 2 more times. So we do it for the current 0, and then current 1. Okay, and with this we set all the 4 values to 0. So again, we could have used query selector here, but we used the getElementById method, which is a bit faster. And also because I want to show you that query selector is not the only way that we have to select elements. So let's now check this out. And indeed, everything is now set to 0. Alright, are you excited to continue with this? Then come with me right to the next lecture. In this lecture, we will continue to build our project and developing the game logic. So in this lecture, you will find out what the ternary operator is, and you will learn how to add, remove, and toggle HTML classes. Alright, so we are still in the event listener, which controls what happens when the user clicks on the roll button here, right? And so we already calculate our random dice number, and we also already display the corresponding dice number in the middle of our user interface. So now we need to continue developing our game logic here according to the number that the user rolls. So if the user rolls a number different from 1, then the score gets added to his round score and he can continue to play, and otherwise, if he rolls a 1, then it's the next player's turn. So let's do that using an if statement, right? So if the dice is greater than 1, then add the score. So add score, and if not, then it's the next player. And I really like to do it this way. So write our if statement first and then add a comment telling what I'm going to do. So here I said that the dice number should be greater than 1, but I could also have said simply that the dice should be different from 1. And since we already know this one here, I'm going to show you the difference operator, which is simply this exclamation point and then equal equal. And this is the one that doesn't do type coercion. So remember, the equality operator, we have the triple equal, and this one doesn't do type coercion, while the double equal does type coercion, and it's the same for the different operator. So we have this one which performs type coercion, while this one with the extra equal, which does not perform type coercion. So we always want to use this one. Alright, so let's add the dice result to our round score. So we have round score, and now I'm going to use the operator that I showed you in the introductory lectures, which is the plus equal operator. And now I can simply add the dice. Right? So once again, this would be the same as writing round score equal the current round score number plus the dice. But this here is much simpler and cleaner, so that's how we do it, right? And again, we can use the round score variable right here in this function because it was defined here in the global scope, and therefore, due to the scope chain, we have access to that variable in here. So we updated our internal variable value, but we also want to display it in the user interface, right? And we actually already did that down here, which I deleted, but we can get it back from here, right? Because you already know how to do this. So remember this trick here that works with the active player. So if the active player is the number 0, then the current 0 element will get the text content. And if it's player 1, then the current 1 element gets the content. And the content that we want is, of course, the round score, right? So each time after the player rolls the dice, we want to first update the round score, and then display the round score in our user interface. And that happens in this element with this class. Okay, so let's quickly see this in action. So I'm refreshing and now roll the dice. So this is adding here because I have the active player as 1, right? So let's quickly change that, because the default will always be that the first player begins, so player 0. So refreshing this, now roll the dice. So 5 plus 4 is 9, plus 2 is 11, plus 6 is 17, so yeah, this is working. So let's see if we can catch a 1. So 34, 36. Alright, so here's the 1. So this time we didn't add the 1 here. Now what we want to happen is that now is the turn of player 2, right? So let's implement that. And we're going to do that here. So if the player does something that is equal to once, then we want the next player. So the first thing that makes sense to do now is to change this variable here, right? So active player will change from 0 to 1. And how do we do that? So if it's 0, then we want 1, and if it's 1, we want 0. So it makes sense to use an if statement here, right? Actually, we can use something else, which is still an if, but it's an easier way to write it. And that's called the ternary operator. And it simply works like this. So the active player is what we want to test. So we still have our test condition here. So if it's 0, then active player should be 1. Else active player should be 0. Okay? So this is the exact same thing as writing if active player equals 0, then active player 1, else active player 0. Okay, but this is much cleaner and much simpler, right? So for a very simple if statement, such as this one, I like to use the ternary operator instead. Okay, so let's see what happens then with the score. So we need to catch a 1 here. Alright, so now we have a 1, and now we should continue on this side, right? Because now it's player 2. Okay, so now we have a score here. But the thing is that we didn't restart at 0, right? We still continued with the 17, so 17 plus 6 makes 23. But we of course want to start this player as 0 as well, right? So there's something else that we need to do here, which is to set the round score back to 0. Okay, so when one player rolls a 1, then the other player becomes the active player and the round score is reset to 0. And now it should work, right? So and now it should go to the other player. Alright, so 3 and 1 again, so now it's this player's turn again. And alright, we start from 0 again, and the game keeps working. Now there's still a couple of things that we need to do here, right? Because as we know from the rules, as soon as the player rolls a 1, he loses the score. So it should be set to 0. So it should not be set only to 0 here, but also in the user interface. So you need to do a couple of things here. So let's select these. So current 1 and current 0. And once again, we're going to use the getElementID method for that. So document.getElementById, and now it's current 0.textContent. We want that to be set to 0. And the same thing, of course, for the number 1. Okay, and another thing that we should also do is to make it visible in the user interface who is the active player. So what I mean is this bold text here and this red dot, and also this gray background. So let me first show you in the HTML how that is actually achieved. So in here we have this active class on the player 0 panel that we do not have in the player 1 panel, right? So it's this class here that makes all the difference. Let me remove it from here to show you the difference. Alright, and now this is not active. So right now player 1 looks exactly the same like player 2, right? So what we have to do is to, as soon as the player changes, we have to remove the active class from the player 0 panel and add it to the player 1 panel. And this is one of the really cool things that we can do in JavaScript to style our applications, is removing and adding classes like this, like we're going to do now. So we need to, as you already know by now, start by selecting the element that we want. So document.querySelector, because it's now a class. So this one was called player 0 panel. And then we need a class list. And in here we have a couple of methods to add, remove, and toggle classes. So let me first show you the remove one. Remove. And now all we have to do is to pass in the name of the class that we want to remove. And it's as simple as that. So now the active class will very simply get removed. And just before reloading the page, let's then add a class to the other panel. So query selector and player 1 panel. And once again, we need to use class list, and then we can simply say add. And once again, we need to specify the class that we want to add. So let's now see this. All right, so I'm waiting for the 1. All right, so here it is. So the active class was removed from here and added to here. And like this, we can now visibly see here that player 2 is now active. And the other change that we did before is also reflected, because this is now back to 0. Okay. But now you saw that I rolled a 1 before. I actually clicked a bit too fast here, but the player didn't change. And of course it didn't, because we didn't tell the code to do so. So let's go back. And one way that we could do this would be to say, alright, if the active player is 0, then do it like this. So remove the class from 0 and add it to player 1. But there is a better way, because we not only have remove and add, but we also have something called toggle. And what toggle does is to add the class if it's not there, and if it's there, to remove. So in this case, if player 0 has the class active, then it will remove it. And if it does not, then it will add it. Alright, so I will leave these here as your reference. Okay, but I will now do it differently. Okay, so I don't want to remove, I want to toggle. And here the same thing. And now it's going to work. Alright, so it changed to player 2 and it changed back to player 1. Alright. Okay, very nice. And now one last thing that I want to do is to also, when a player rolls a 1, to hide the dice again. So that when the next player's turn is, we don't have any dice here visible. And that's pretty easy, we already did that, right? But without looking at the code, we know that it's document query selector, and it's the dice class actually. And then we need style, and then we just need the CSS property that we want to change. And this one is the display property, which we are setting to none once again. All right. So let's reload this Alright, so I rolled a 1, but it disappeared and now it's the next player and he has like an empty spot here to roll his dice. Now up until this point we have no way to hold our points so that they get added up here in the global score, right? So that's what we're going to do right in the next lecture. In this lecture, we are going to implement our hold function and also talk a little bit about the don't repeat yourself principle. So we will continue using the concepts that we have been learned so far, and we will also learn how to use functions to correctly apply the don't repeat yourself principle. And of course, we will continue thinking about the game like a real programmer. So let's do that. So this is where we left after the last lecture. So far we can roll the dice and add our scores down here, but there's no way to hold our points and update our scores here in the interface. So let's now do that. So once again, we are going to set up an event listener, and this time it's going to be for the other button. So let's check out which one that is, and it's called button hold. Alright. So let's start by selecting it, and by now you already know how to do that. So query selector and then button hold, and then add event listener. Okay, and we want this to happen on the click once more, and we're going to use an anonymous function, which, as you remember, is a function which doesn't have a name and that we cannot reuse in another point of our code. Okay, so we simply write function like this, and we have no parameters, and now in here we can write our function body. So let's first define what we want to happen as soon as the user clicks the hold button. So the most obvious thing is, of course, to add the current score to the player's global score, right? So once again, I'm using these comments here to first define what we're going to do and then fill it with the code. So add current score to global score. Then we of course want to update the UI, the user interface. And there is another thing that we can and should do right here in this function, so when the user clicks the hold button, which is to check if the player won the game. So let's add that here too. Check if player won the game. So once again, when we hit the button, then the score that we have in that round gets added to our current score. Then we print that number to the user interface, which means that we perform some DOM manipulation, and then after that we check if the player won the game. So let's start right here. So this one should be easy, right? Remember that right in the beginning, right in the first lecture, we created this variable here which stores the scores for both the players. And that we also have this variable here which stores the active player. So player number 1 is 0 and player number 2 is 1. And we can now use this variable to access, to read or to write, in this case, the scores right into this array. So if the first player is the active player, then this is 0, and so we can say scores 0, and then we will have the value in here. And if the second player is the active player, then this is number 1, and then scores 1 is this element. So let's now do that. So scores, and we use the curly brackets to access the variables or to mutate it. And now we simply have to write active player, right? And what will this score actually be? We will simply add the score that the player got in this round to the score that the player already had. So it's as simple as this, so plus equal the round score. And remember that this works because this is the exact same thing as working it like this. So active player equals the score that the player already had, and plus the score that we got in this very round score. Alright, so this is the exact same thing, but once again I prefer to use it this way here, okay? So I'm just going to delete this, just wanted to show you that this is the exact same. So I hope that makes sense. Now we want to update the UI, and in order to do that, we first need to know where we have to write our data. So it's here in this ID score 0 for player 0 and score 1 for player 1. So let's do that here with document.query selector score, and then we're once again going to use our simple trick where we use the active player variable to construct our string name here, basically. So active player like this, so that we don't have to specifically write score 0 or score 1. And here we just missed this, and now we're good to go. So we have our active player score selected in the user interface, so let's now change the content. And if you remember from the last lectures, we use that simply using the text content method. All right. And what are we going to print here? It's simply the value that we defined before. So we go in our scores array once again, and then select the points from the active player. So if it's the first player, it will be the first element of the array, and if it's the second player, then it's going to be the second element of the array. So let's check out if this is working as intended. So I roll the dice and I hit hold, and alright, here we go. So we have 8 points now here. Now what isn't happening here is that it isn't changing the active player, because remember, when we hit the hold button, we store our points and then it's the next player's turn. But that's not happening right now, so we have to implement this right now. And you probably remember that we did exactly that in the last lecture, right? Because it's exactly that happens when the user rolls a 1, right? So basically after the user rolls a 1 and after the user chooses to hold his points, it's always the next player's turn. So it's the exact same code, so we can just copy this down here to our other function. Now this doesn't make much sense, does it? Why should we have the exact same code in two places of our application? Imagine that we have to change something here, for example, I don't know, this class name here or some of these class names, and then we also would have to change it up here. So this is very difficult to maintain, and it's not a good practice at all. In fact, it's a really bad practice, and that's why there's something called the don't repeat yourself or dry principle. Of course, as the name says, that we should not repeat ourselves in our code. So what can we do in order to apply the don't repeat yourself principle? You guessed it, we are going to implement a brand new function. And this one is going to be called next player. So function next player. And now we're just going to paste this code here, and we have our function. So it's a function that doesn't receive any parameters, and it also doesn't return any result. We simply use this function in order to not repeat our code. So we defined the function, and now we can actually use it. So we are going to delete all of this and simply call next player. And then of course the same thing here. So deleting all of this and next player. And just like this, we use the dry principle. So this is something really important in programming in general. So let's check out if this works. So holding, and alright. So we're back to 0 here. We have updated our score here, and player 2 is now active. And we keep rolling the dice. So we have 5 and 6, so we should have 11 as soon as we hit the button. And alright, it's working, great. Oh, rolling a lot of 1s here. Yep, so it's working on both sides, right? So let's go back. Now there's only this thing here to do, which is to check if the player has won the game. So let's just check out the rules of the game, which says that the first player to reach 100 points on global score wins the game. So this should be pretty easy, right? So can you guess what we're going to do here? Take a moment and try to actually implement this for yourself, okay? So pause the video to try to implement this functionality. Okay, so I'm sure that you got this. So of course we are going to use an if-else statement. So what we have to do here is to check if the score of the active player is now more or equal to 100 points. So once again we use our scores array, where all the scores are stored, and then retrieve the score for the active player and check if it's greater or equal to 100 points. So of course we cannot use just equal to 100 points, because that wouldn't be fair, right? Then a user with, let's say, 105 points would not get the chance to win. So it must be equal or greater to 100 points. And just to check if this works, we are going to display something on our web page, on our game, and we're simply going to replace this player 1 name here, or player 2, whoever wins, with the word winner. So the ID for this is name and then the active player. So document.querySelector. So the ID, name, and then our old trick again. So by now I'm sure this makes total sense to you. So again, text content. And now we will just say winner. And now in order to check this, I'm just going to put this down to 20 so that you don't have to watch me playing the game up until we reach 100 points. So I'm going to put this to 20 now just for testing, and then I'm putting it back to 100 later. So roll the dice, 15 points. And now if I hold, 15 plus 8 should already be more than 20, which is our winning score right now. So I should now be the winner. And yes, it works. Great. Now, what doesn't do much sense is that now it's the next player's turn, right? So let's change that with our else part of the if-else statement. So if the player wins the game, we want this to happen, and only if he doesn't, so if the game continues, then we want the next player to play the game. So let's copy this to here. All right. So let's see this now. $12, $15, okay. Let's say if I can push this even more. Yes, so hold. And now player 2 won the game. So all we have to do now is to actually hide this dice here, I would say, and also remove the active class here from the current player, right? So let's do that, and it's not the first time we did this, of course. So we're doing it right here. So document.querySelector, and it's the dice class. So once again, we're going to change the CSS style. Display. We are going to set the display back to none. So now it will not be visible anymore. Now, one note about this way of styling our web page and changing the CSS. So it's not the best way to mixture or CSS with JavaScript. So if we have a lot of styles to change, we shouldn't do it this way. So we shouldn't really use the style property all the time here in our JavaScript code, but instead do it the way we did it, for example, down here in our next player function with the toggling or adding or removing classes. So instead of writing a bunch of lines here to manipulate the CSS, we should simply create a class in our CSS and then simply add or remove this class here in a JavaScript. And that's exactly why I created the active class that we have used already. And it's also why I created a winner class. So let's see this. So let me see where this is. Alright, so down here. So it's not a lot of CSS, but it's just to show you that it's always a better way to create a class like this instead of doing, for example, these two manipulations directly in CSS. So let's now apply the winner class to the entire player panel in order to make the winner look a little bit better, let's say. So these player panels here, so which are the entire left or right side of the user interface. So let's do that right here as well. So document.query selector. And now the player that won this game is of course the active player, right? So only the player that is playing right now can win the game. So player, and then we use our trick with the active player, and then plus panel. So player 1 panel or player 0 panel. And now we use the class list again, such as we did before, to access the classes that this element has. And now we simply add the winner class, which is the one that I showed you before in the CSS. And what I should also do is to remove the active player class also from this panel. So I'm just going to duplicate this line, and then here it's not add anymore, but it's remove. So the active class. So remember, we have add, remove, and also toggle down here. So remember, what toggle does is to add the class if the class is not there, and if the class is already there, it removes it, which in this case is not necessary because we know that the winner class is not there, so we add it, and we also know that the active class is there, and so we remove it. So let's now check this out. Remember, I'm still at 20 points for the final goal. And here we go. So I won the game, and I'm no longer the active player, as you see here, as the dot disappeared, and also my winner score here is now red and big and bold. So this is already pretty cool, right? We've come a long way with this application and it's almost ready. There's still some problems because first, now if we continue hitting this button, we can still roll the dice, which doesn't make sense, right? And we also have this button here that we want to implement. So if you want to do that right now, then just hit that next lecture. See you there. So let's continue our coding journey. And we're getting really close to having our first real JavaScript application. So by now you have already learned a lot of stuff about DOM manipulation and even other things. So in this lecture, we will just continue practicing some of these things and implement another feature in our game. Alright, this is where we left our game. So let's now implement this functionality here. So when we hit this button, that the game starts from the beginning. So if we have a button and an event, then of course we need to listen to that event. So once again, we will use an event listener. So let's check out the name of the button, and it's simply button new. So document.query selector and button new. And by now you already really know how to do this. So add event listener, and once again we are listening for a click. And we will once again use an anonymous function here, which by now you know in your sleep, right, what this is. Okay, cool. So what do we have to do when we want to start a new game? The first thing that I can think of is that we have to reset our player scores. So we set our scores back to 0 and 0. And we also have to say that the active player is back to being 0, because that's always the player that starts, so the first player. And also if there is some round score left from the last game, so from the game that we were playing, then we also need that back to 0. So round score should be 0. Okay, so if this is starting to look familiar to you, then you're not the only one, because actually we already wrote that exact same code up here, right? So this is not ideal, not at all. So once again, we should stick to our dry principle here. So not repeating our code. So what can we do here? And you guessed it, once again, we are going to use a function. And I'm calling this one init function because this is to initialize the game. And the logic behind this is that once again, we will write a function, and then even before doing anything else, we will run that function, and this will then initialize or start our game. So not only when we hit a new game button, but also right in the beginning when we first load our application. So I'm going to delete this from here, okay. And I'm writing my init function now. So function, simply init, and again it doesn't receive any parameters. We just want to use this code. So I'm removing it from there and putting it right here. And then all we have to do is to simply call the init function right in the beginning. So the first thing that we do is to call the init function. And so that piece of code that we had here will then be run. Now the things that you see here are also things that are done right in the beginning of the game, right? So of course it also makes sense to include this right into our init function. So all the things that happen before we can start to play will now be placed right into this init function. So we call this function as soon as we load our application. But remember, we also want to call this function when we hit on our new game button, right? Okay, so we could do it like this. So we can simply call the function in here now, and that's it. But there's another way of doing this, because why should we create an anonymous function here, right? So this anonymous function only to then call another function. So it doesn't make much sense. Actually, as we set up our very first event listener, I told you that we can write any function in here, in this argument. So I'm just going to delete this, and what I can do now is to not call the anonymous function, but instead our init function. And actually I'm not calling it, I'm just passing it here into this event listener function, this method. And that's why I don't need to use the function call operator here, which is this one, because if I would, then this function would be immediately called, but I don't want that to happen. I just want to tell this event listener that, hey, when someone clicks this button, then please call the init function for me. So that's all that I'm doing here. So back to our game init function, which starts the game. Another thing that we have to do here is to actually change back the player names. So when someone wins the game, we print winner here. But when we start a new game, of course, we want to say player 1 and player 2 right there. So let's do that as well. And we know from up here, yeah, it's right here. So we know that these are called name and then the number of the player. And actually, let me just copy this from here, because by now we already know in our sleep how to do this, right? So we have to do this for name 1 and 2. So we don't need this active player variable here. So player 1, and now I'm simply duplicating it here for player 2. So player 2 here. And since we are using get element by ID for all of these IDs here, let me just do this here as well. So get element by ID. And now remember, we have to remove this hash symbol because this is only for the query selector. So this looks pretty cool. So let's now check this out. Alright, so let's roll the dice. Well, nothing's happening, so we probably have some bug somewhere. So let's open up the console. Alright, so we cannot say text content of null in line 93. So let's check out where that is. And of course, I did a big mistake here, right? And you probably already saw it coming, because the players are not 1 and 2, but they are 0 and 1. So of course I cannot set the content of an element called name2 if there isn't one on the page, right? So let's now load this. And yeah, so it actually works. So we already know that it works because before we had some different values here, not 0, 0, 0. But we see that our init function is already doing its work by setting everything to 0, just because we call it right in the beginning. So right here, before doing anything else, we call this function. So let's now play. Hold, and now player 2. And hold. And with this we can already win because remember it's still set to 20. So I'm saying hold, and now I win. Cool. So now if I hit the new game, let's see what happens. Alright, so we are back to 0 points here and here, but what we still have is this winner class here which formats this text arrayed, and also the active class. So we need to do a couple more things in our init function. So first thing is to remove the winner class. Let me actually check where we put this winner class. Alright, so we put it here. So let me copy this to make our life a bit easier and just paste it here. Alright, so player 0, and this time I'm not making the same mistake and now not adding but removing. And since we don't know who won the game, we will simply remove this class from both. So it doesn't matter, even if the class is not there, we can call the remove method without any problem. And actually we will do the exact same thing for the active class. So a class that defines or that shows which one is the active player. So again, of course, only one of these is the active player, but we have to remove it from both because we don't want any of them to be the active player. And now only one thing to left, which is to set the first player to the active player. So I will just duplicate this line and set it to add. Now this sounds a little bit strange, right? First removing it and then adding it. But I'm doing this because imagine that player 0 was the active player. Then in this case, the active class would be there. And if I then call this method here, so this line, then another active class would get added. And then we would have two active class, and of course we don't want that. Because if we later went to remove that class, then there still would be one left, and then the styles associated with the active class would still apply. And we don't want that. So we need to always remove them. And actually let me put this down here so that the ones that belong together are together. So we first remove these two so that we are sure that no active class is anywhere, and then we add the active class back to the first one. And with this, we should be good to go. So player 2 is in the lead this time, but I'm still rolling a lot of ones. Alright, so I'm going to let player 2 win. So I click hold, and alright, player 2 won. Everything looks nice. So now look at these numbers and at here when I hit the new game. Alright, so this works just fine. Everything is back to 0. Player 1 is the active player, the winner class is also removed, and everything is fine. So if I play again now, let me hold it here. Okay, so I won. Now, it makes sense that the game stops with this, right? But instead, if I continue hitting this, the game continues. And now we have two active players, and all of this is really weird and not working the way that it should be. So there's one more thing to do, and that will be in the next lecture. So if you're curious on how to solve this problem, then don't wait and come right with me. Now the time has come to finally finish up our application with only one small thing to do. So in this lecture, you will just learn what a state variable is, how to use it, and also why to use it. And this is really something about programming in general and not just JavaScript. So remember that the problem here was that we can continue to play the game even after we have a winner here. So this starts to look really weird and really not what we want. So we need something called a state variable. So what is a state variable? It's actually very simple. A state variable simply tells us the condition of a system. So that's the definition. And we need a state variable when we need to remember something or the state of something. And in this case, this will be, is our game playing or is our game not playing? So we will simply create a variable that tells us this and that we can then use in our function. Because there are, of course, a lot of things that we only want to do when the game is active, when the game is playing. So let's do that. And keep in mind that we want to use the variable in a couple of places. So imagine if we would just declare it here, like saying var game playing is true. Now, if we declare it here in this init function, then would all the other functions have access to this variable? And I know that you know that the answer is no, because of the scope chain. So all the functions do only have access to the global scope or of course the scope of their parents. So here, the init function is really the only function that would have access to the game playing variable. So we need to define it outside, so right in the global scope. And that's also the reason why all of these are here in the global scope. So I'm just writing it here, game playing. Once again, I don't need to define it here, I simply need to declare it here. I need to say this is a variable that is defined here in this scope so that I can use it then in other scopes, in other functions. Okay, so when we start our application, the game playing variable will be set to true. So let's now work through our functions here to our event listeners one by one. So this one is for the event that happens when we hit our roll button. So we create a random number for the dice, then we display, and then we update the round score. Now we only want all of this to happen when the game is actually playing, right? Which means that we don't have a winner yet. And that's because the game playing variable will be false only after we have a winner. So after this weird situation that we saw before happens. So by then we want it to be false. But before, all the time during our game, we always want this game variable to be true. So what can we do here? It's actually very simple. All we need to do is to add an if statement here. So if game is playing, then we do something. And why does it work like this? So why do we only need the game playing variable here and nothing else? It's actually very simple. That's because the condition that the if statement wants here is a true or false value. And usually we use an operator here which returns a true or false value. For example, down here, we check if dice is different to 1, and this returns either true or false. But in this case, the game playing variable is already true or false, so we don't need anything else. Okay, so now all we want is to have this code right here. So all this code is now wrapped in this if statement. So all of this only happens if the game is actually playing. So after the game is finished, we can push this button as hard as we want and nothing's going to happen anymore because this will be set to false. So let's actually set it to false before we forget it. So what do you think is the perfect place to set this variable to false? I will give you a minute to do that by yourself. Alright, so I'm sure you figured it out. And so the perfect place to set this variable to false is here, right? So this is where we detect if a player wins a game. So after he won, which is this condition here, so when his score is greater than 20, which I still have to set back to 100, so right here, we will turn this variable to false. So we say game playing should be false. And that's it. That's all there is to this mechanism. Simply setting our state variable to false will avoid this situation here. Of course, together with this if statement here, right? Now, what else do we have here? Okay, where is the other event listener? Ah, yeah, it's right here. And once more, we also want all of this only to happen if the game is playing. So we can only hold our points if the game is actually active, right? So we'll do the exact same thing here. So if game playing, then do all of this stuff here. And of course there's not an else, because we don't want anything to happen if the game is not active. Alright, and that should be enough to make our game work perfectly fine. Eight, 11. Okay, now this player's turn. Alright. So we have a winner, we have 22 points, and let's see what happens if we try to keep rolling our dice. So, nothing happens. The game has effectively stopped. We can also not hold. And let me check if we have any bugs in our code. Actually no, so no bugs here. So it's not working because we blocked it with our code. So our if statement is really working, meaning that our state variable game playing is currently false. Now if I hit this new game button here, then remember the init function is called, and the init function sets our state variable game playing back to true. So now it should be working again, right? So let's hope it does work. And yes, it does. Great. So another winner, and again it doesn't work. Alright, so that's it. That's the end. This is your very first JavaScript application, and it's fully functioning now, and it's really working great. So now I hope that you're really proud of what we have achieved so far together here in this course, and especially in this really cool section. You can play this game with your friends and then tell them that you coded this by yourself. How cool is that, right? Really, just go play this game with your friends and let me know what they thought of the game here in the comments. I'm waiting for it, really. Alright, if you still haven't got enough of this game, then here come not one, not two, but 3 coding challenges just for you. So after finishing this game, I had 3 ideas about rules that we could change in this game. So I thought that these were 3 really cool challenges for you to do. So here they are. So the first one is that a player loses his entire score when he rolls 2 6 in a row. So not just the round score, but really all of his score. So 2 6 in a row, and then the player loses his entire score. And then of course it's the next player after that. And one hint that I can give you about this is that you should always save your previous dice roll in a separate variable so that you can access the present and the past dice roll at the same time. The second one is that you add an input field to the HTML where the players can by themselves set the winning score, and so they can change the predefined score of 100. And again I have a hint, so in order to read the value from the input field, you can use the value property in JavaScript. And if you can't manage to make this working, then this is a good case for you to use Google to figure out the problem. This 100 here brings me to correcting what we still had here. So we still had 20, but of course the original rule was that the game ended at 100 points. Alright, and so the third challenge is to add a second dice to the game. And in this scenario, the player loses his current score when only one of them is a 1. And for this one, you are going to need some CSS and of course HTML to position the second dice. So if you have a hard time with that, then you can just look at the CSS code that I provided for you. And if you still can't manage to do that, to position the dice, then you can simply watch that part of the solution, right? So I really encourage you to do all of these 3 challenges, because this really allows you to get immediate practice with the coding, but also with the thinking about these solutions. So that's really the best thing that you can do right now if you really want to learn JavaScript. And that is why I designed these challenges for you. Okay, and after you did all of them, then you can just check the solution that I have for you in the next video. This is the first part of the solution for the coding challenge that I just gave you in the last lecture. So let's start by creating a new file which has all of this code so that we don't mess up our original code. So I select and copy all of this, and now I'm just creating a new file here. And this one will be called challenges.js. So I paste all my code here, and I will put these challenges at the top. Don't need this one here too. And we already know the game rules. Alright, so here are our 3 challenges. Actually, another thing is that now I have to comment out this part of the code and link our new JavaScript file to this HTML document. So script, source, and now challenges. Okay. So let's start with the first one, of course. So a player loses his entire score when he rolls 2 6 in a row. So as I already mentioned in the hint, we need a variable where we can store the previous dice roll. So let's do that. And of course, we are going to do that right here in the function, which handles all of our dice number generation and displaying in the user interface. So our dice value is generated here. What I'm now going to do is to create a variable at the very end of this function, but still inside of this if statement that we added in the last lecture. So here I'm going to declare a new variable var last dice, and what I'm going to do is to set it to dice. So let me explain that. So we generate a dice number here, then we do all of this stuff, and then we check the dice number. So if we then store the last dice number, we can use that variable the next time that the function runs. But actually not yet, because this variable should not be declared here, but in a global scope. So let me simply create a new var here, last dice. And the reason for that is that once the function returns, so this function here returns, then the value of last dice will get lost if we only declare it in here. So for example, the value stored in this dice variable here will not be accessible to us after this function returns. But we need this last dice value the next time that someone hits the roll button. And that's because now, down here in our if-else statement, we are going to add another condition. So we want the player to lose his score when the current value and the last dice value are both a 6. So how do we do that? So dice must be 6, and now the Boolean operators are back. So the dice value should be 6, and the last dice should also be 6. And then player loses score, and then of course we still also want this part here. So else, and then the rest of the code that we already had. Okay, so once more, at the end of this function, we stored the value that we rolled with our dice in an external variable. So a variable that was defined outside of the scope of this function here. So we do that at the end of all this code here, so that the next time that someone rolls the dice, we have still access to that variable and can then perform this check here. When we just rolled a 6 and we rolled a 6 the last time, then the player loses his score. And if this does not happen, then we of course apply the logic that we had before. Alright, so how does the player lose the score? Remember, we use the scores variable, which is an array, to store these values. So all we need to do is to set it back to 0. And such as we have done all the time, we use the active player variable here to define which score it is from the first or the second player and set it back to 0. So that's really simple. And then of course we need to update the DOM as well, so that on our web page we see this value 0 as well. So instead of writing it all over again, make it a little bit quicker, I will just get it from down here. So now it's not scores, Well, we could actually leave this as it is here because scores active player is now 0, but we can also just set it to 0, right? Because we already know that that is the value. And what also happens then is that it's now the next player's turn. And so therefore we once again use our next player's function that we created before to apply the don't repeat yourself or dry principle. And now this should work. So let's come back here and refresh this. So let's try. Actually, I should hold because otherwise there's no score to lose, right? Alright, so we see we lost some score here. We didn't see it because it was too quick. So let me try it again. Alright, so here we had it. Once again, we lost the score here after rolling 2 6 in a row. It's not really visible in the video, but I actually clicked twice and there were 2 6s and we lost the score. And I'm sure you will experience that for yourself as well. So in the next video, we have the solution for the second challenge. Alright, here goes the second part for our current coding challenge. So this time our task is to add an input field to the HTML where players can set the winning score, and then we can use the value of that in our code. So let's start by doing that, and I'm going to put it right down here. So what we need here is an input element. So input and the type of text. So text, we also want a placeholder here which tells us final score, and let's just call it with a class final score as well. Alright, so really simple. And now we also need to style it in our CSS in order to make it visible. And I will just put it here at the top. So the class selector and then final score. So this will be a bit of CSS. I'm not going to really explain this. I'm just writing the CSS that is necessary to style this, also based on the rest of the code that I already have here in this file. So this is a nice little technique to center it in a page. Translate x minus 50%. Okay, and from the top I want it at 520 pixels. The color is the same as the rest of the page. The font size should be 18 pixels. And we also need to set the font family for this one, which is Lato in this case. We want the text in the center. And also some padding, let's say 10 pixels. And we want the width to be 160 pixels. And we also want a text transform of uppercase. So you see that I care a lot about design. So this really has to look the way that I want it to be. So let's now reload and see how this looks. So here's now our input field. Let's just remove this weird blue border here that we have when we focus it. So final score focus outline none. Okay, so now back to our JavaScript. And the question to ask here is, where are we actually going to use this value? So the value that the user is right in there, the number, where are we going to use it? And the answer is, it will be in the part of the code which checks if the game is finished, so which checks if someone won the game. And this is exactly in a function associated with the event handler, which handles the event that someone clicks on the hold button. So it's right here. So right now we simply assume that the winning score is 100. But now we want to read this value from the input field and use that one. Let me just add it here in the code. So I'm going to call it input, very simple. So I'm going to select it using the query selector. we know that it's called final score. And now, instead of using text content or inner HTML or something like that, I simply use the value property. And this will give me the content that the user put it into this input field. And just to see how this works, let's console log this result to our console. So input. Alright, so let's now just check this out. I will reload this, open up our console. It doesn't have to be this big. Okay, and let's play the game and hold. And now we don't have anything here because this is empty, right? So if we continue playing, we will always have this empty here. So now it's twice the empty because we already clicked 2 times here on hold. Now let's put 50 here or something. Continue to roll the dice and click hold. And now it's 50 down here. Cool, right? So we can continue to roll and hold and then change this value to 200. Roll the dice, hold, and now it's 200. So the winning score by now would be 200. So the players can even change this during the game. Alright, so let's now use this value. So don't need this anymore. And alright. Now what happens if the users don't put any input into that field? Then we don't want to use the value, right? So we first have to actually check if there is a value. So we need to check if the input variable is not empty. And that's actually also pretty easy to do. And that's because, once again, type coercion. And I will actually write it down, which is that all the values of undefined, 0, null, or even the empty string, like this, are coerced to false. So if we have a condition like in an if statement, and I'm actually going to write it. So if we have something like this, so a condition here, then JavaScript will try to coerce this value here to a true or false value, so to a boolean. And in case that the variable that we have here is set to undefined, to 0, to null, or to the empty string, then these are coerced to false. And anything else is coerced to true. So if we would check this with something else, for example with the scores variable, so if scores, then this would return true, because it's not undefined, not null, not 0, and also not an empty string. In this case, the value of this input when the user doesn't put anything into the field is actually the empty string. So we only want to use this input if it's not an empty string, so when it's true. And down here in this if statement, we actually already have that. So if there is an input, so if input is true, then we want to do something. And that something is to create a new variable called winning score, in which we then store that input. And we need to do that because in the case that we don't have an input, we can store something else in that variable. So winning score is then the original 100 that we defined before. And so now, instead of always using 100 here, we use the winning score. And of course, this variable definition should not happen here, but outside from this if-else statement. So I'm just putting it here. And alright, here we go. So once again, when there is an input, which means that when the input is coerced to true because it's not the empty string, then the winning score will be set to the value that we just read from our input field. But if there is no input, then the winning score should be 100. And we can then use that winning score down here. So let's now check this in action, reload our page, and input a 10 here. So this should be a really quick game. Alright, and yes, it works, so we have a winner here. Nothing else works, so the game has finished as usual. And so we can now try this out with another value. So we could even start without anything, holding again, and then setting it to say 20 or 25. And we still don't have a winner. But now we should have. And yes, player 2 won the game. Alright. So challenge 2 completed. For solution of challenge number 3, just go to the next video. Finally, here goes the last part of the solution of our coding challenge. And this coding challenge is a really fun one, because this time we have to add another dice to the game, and then we will have 2 dices instead of just 1. So let's now do that. So the dice is down here, and I will just duplicate this line, and now we have 2 dices. And since they are different, we need a way to identify them both separately, and therefore I'm going to create an ID called dice1, and down here we will have an ID. And you can imagine that this will be dice number 2, right? And now just for the CSS, it's also quite simple because all I have to do is to position them. So I just need to specify their top. So top of this one will be 120 pixels, and then duplicating it, and 250 pixels for the second dice. And since they both share the dice class, all of these rules here appear to both. Alright, so let's, before we start coding, see how this looks. Actually, we cannot really see how this looks because one of the dice gets hidden, and that's because of the code that we wrote exactly to hide the dice. So maybe let's start by changing that code. So it's right here. So as I mentioned right in the beginning, probably in one of the first lectures of the section, the query selector only selects the first occurrence of the elements with this string here. So we could use the query selector all method here, and then we would have to use a for loop or a while to loop through the results. And we will do that later in the next project, but for now, let's keep things a bit simpler. And I will therefore just use the select element by ID method here. So I don't want this anymore. I'm just going to say document.get element by ID, and the first one is called dice1, and I'm just going to set its style, or better, its display property to block, so that we can see it here. And the same thing for the second one. So we don't need this one anymore. And now, since this variable here is gone, I will also simply go ahead and replace this code with this part here. Okay, so dice1 will be the value of dice. Now, we still only have one dice value, right? So we need to fix that as well. So I'm going to create dice1 instead of dice, duplicate this line, and create dice1 with the exact same formula. So if this runs twice, we already know that the math random always generates a different number, so these will be 2 different numbers. Not always, but generally there will be 2 different numbers. So now here it's dice1, and then duplicating this line, we will have dice2 here, and then the value of the random dice roll. Alright, and now down there, in the places where we actually hide the dice, now I will need to change that as well. So for example, in here, we have the dice. Now we need to put it to none for both. And the same thing here as well. None and none. Now maybe you're thinking, oh, I'm repeating a lot of code here. I could just create a function instead. And yes, that's true. You could actually create a function called hide dice, for example, and replace this code by that. And would actually make some sense. But in the solution of this coding challenge, I'm not going to do that. But of course, you can try it out and then see for yourself that it's going to work too. Okay, so here we are back. And actually let's comment out this part here from the last challenge. Actually this one as well. So we don't need this less dice thing, okay? Because what we want is only this, what we had before. Or let me just copy it from the original, okay? So it's less confusing like this. So we want the original part, so this. Okay. So this is what we had before. If the dice is different to 1, then everything happens normally. But now it's different, because now it's enough for one of them to be 1, and then we lose our score and the next player's turn is. So what has to happen that we can continue playing and that our score gets added? So the first dice, of course, needs to be different from 1, and at the same time dice 2 also needs to not be 1. So this solves coding challenge number 3, and let's now test if this actually works. So in the beginning there's no dice, as we know. Now if I roll the dice, okay, so here we have now 2 dices. But there's still one problem, because here we don't have a number right now. So actually the problem is not yet solved. So let me look at the console here, and there we have an error. And an error happened in line 32, where we see that we still were using the old dice value. And actually, yes, we did. So of course we don't want the dice here anymore. But now what gets added to our score is not only dice 1, but of course the sum of these two. So dice 1 plus dice 2. So that's what we're missing here. So closing this, and once again roll the dice, and yes, now 4 plus 2 is 6. Hold it, and then next player, oh, and he once again rolled one of them was a 1, so it's right back to player 2. So yeah, this was challenge number 3 with 2 dices. So we did 3 nice changes here, which hopefully helped you get a bit more practice with your JavaScript. Alright, so see you soon. Hello and welcome back to the next section. Let's now take a deep dive into the most advanced topics in JavaScript, and that is objects and functions. So objects and functions are 2 closely related concepts in JavaScript. They are also the 2 most used features of the language, because they allow us to do so many advanced things with our code. And so it's absolutely vital that you get a good grasp of everything about objects and functions. Now, some of these concepts may be kind of difficult to understand and confusing in the beginning, alright? But don't worry, that's absolutely normal when you're first confronted with these topics. So just pay good attention, take some notes, and maybe rewatch a lecture or 2 if that's necessary. And if you do so, well, I can guarantee you that objects and functions will be crystal clear after this section. And with that being said, let's now get started with a deep dive into objects. In this lecture, we will take a closer look at objects in JavaScript. We will talk about object-oriented programming in general, inheritance, and how JavaScript handles objects and inheritance through prototypes. This is probably one of the most important lectures in this course, if you really want to understand JavaScript. So, there's a saying in JavaScript which says that everything is an object. And while this is almost correct, it is not 100% correct though. Because in JavaScript, we have 2 big types of values: primitives and objects. And primitives are all the values that have one of the data types that we talked about in the intro lectures. So numbers, strings, booleans, undefined, and null values, all of these are primitives. And everything else are objects. And that's why in JavaScript we say that everything is an object. And in fact, even simple things like functions, arrays, or dates are all objects in JavaScript. And that's because in JavaScript, objects are not just for storing a bunch of data, like we have been doing, but for really complex things under the surface. So we have been using objects all along, just without knowing it. So always remember that almost everything is an object in JavaScript, because it's one of the fundamental things that makes JavaScript so unique and different from other popular programming languages. Alright, so now that we know how important objects are in JavaScript, let's look at object-oriented programming. So, in very simple terms, object-oriented programming makes heavy use of objects, properties, and methods. And these objects interact with one another to form complex applications. We use objects to store data, structure our code, and keep our code clean. So far, we have only created simple objects holding some data. I remember the John object from the intro lectures. And if we had created other persons back then, we would simply have written them one by one, like Mark, Jane, etc., right? But there is a better way. Imagine something like a blueprint from which we can generate as many objects as we want. And we can do that in JavaScript. And right here is an example of that. This is a special person object that we can basically use as a blueprint to create a lot of person objects. In other programming languages, this is many times called a class. But in JavaScript, we like to call it a constructor or prototype. So based on this constructor, we can create as many instances as we want. So here are our Jane, Mark, and John objects once again, but these were created from the person constructor. So they are effectively person instances. And now their name, year of birth, and job variables are defined, and they all have access to the calculateAge method. So again, the constructor acts like a blueprint and is used to create instances, which of course are also objects. We will of course do all of this with code over the next lectures. This is just to give you a very brief overview. And now let's take this even one step further, with inheritance. In simple terms, inheritance is when one object is based on another object. It's when one object gets access to another object's properties and methods. So very simple. Back to our persons example, imagine that we also wanted to have an athlete constructor besides the person constructor, with a couple of different properties and methods. Now, an athlete is also a person, right? There are just some particular properties and methods for an athlete, like for example, how many participations in Olympics they have, or how many medals they have won. So when we define the blueprint, so the constructor, for an athlete, then why repeat the same stuff that we have in our person constructor? An athlete also has a name, year of birth, and job, right? So what we can do is to use inheritance. We make the athlete object inherit the properties and methods from the person object. So then, the athlete not only has access to its own properties and methods, but also the ones from the person object. Really cool, right? This allows us to write less code and make more logical programs. So this is a broad overview of how inheritance works in theory, and in all programming languages that have object-oriented features. So let's now see how JavaScript in particular handles inheritance with our person and John examples. JavaScript is a prototype-based language, which means that inheritance works by using something called prototypes. In practice, that means that each and every JavaScript object has a prototype property, which makes inheritance possible in JavaScript. So again, inheritance is made possible through the prototype property that every object has. Now all of this may look a bit confusing at first sight, but don't worry, because we will do everything in code later as well. But before doing that, it's super important that we get at least a visual overview of what happens behind the scenes. Alright, now how does inheritance actually work? To better understand this, let's go back to our person example, where the person object is the constructor and John is one of the instances. Now, if we want John to inherit a method or a property from the person object, we have to add that method or property to the person's prototype property, just like we see it here. So in this example, we have the calculate age method in the person's prototype property, and therefore John inherits the method and can then call it. And any other object created by the person constructor would inherit this method as well. So again, the prototype property of an object is where we put methods and properties that we want other objects to inherit. What is really important to note here is that the person's prototype is not the prototype of the person itself, but of all instances that are created through the person blueprint, like for example John. So in other words, the person's prototype property is the prototype of John. And that's not even all, because the person object itself is an instance of an even bigger constructor, which is the object object. Yeah, that sounds a bit crazy, but this is actually how it works. Each and every object that we ever create is an instance of the object constructor, which has a bunch of methods in its prototype property. And as you can guess, the person object inherits these methods and can call them. Plus, the John object also inherits these methods and can also use them. And with that, we have actually explained the prototype chain. So, the prototype chain is what makes all this inheritance possible. And here is how it works. When we try to access a certain method or property on an object, JavaScript will first try to find that method on that exact object. But if it cannot find it, it will look in the object's prototype, which is the prototype property of its parent. So it moves up in the prototype chain. If the method is still not there, this continues until there is no more prototype to look at, which is null. Null is the only one that has no prototype, and is therefore the final link in the prototype chain. And in this case, undefined is returned. This is the reason why, for example, the John object could call the hasOwn property method that is stored in the object prototype property. And since this is all so crazy important, I even took the time to write down a summary for you about the most important things about prototypes, so that you can copy it if you want. So here it goes. Every JavaScript object has a prototype property, which makes inheritance possible in JavaScript. The prototype property of an object is where we put methods and properties that we want other objects to inherit. The constructor's prototype property is not the prototype of the constructor itself, but it's the prototype of all instances that are created through it. When a certain method or property is called, the search starts in the object itself, and if it cannot be found there, the search moves up onto the object's prototype. This continues until the method is found, and this is the prototype chain. Alright, so this is it about objects, inheritance, and prototypes in JavaScript. I promise that we'll now finally go back to our code. Let's now finally write some code to use the concept that we talked about in the last lecture. And I will start by opening up the starter project that you can download for this section. And once again, it's on our desktop already. So I just need to open it. And here we have the HTML file, which connects with our script. And here's just the empty file. Alright, so this lecture will be about creating objects using the function constructor. So I'm just writing it here to structure our code better. So I'm going to start by writing our well-known John object, right? So John with the name of John, of course. and the year of birth. And then our job. So this is the way that we have been writing objects using the object literal, right? And now imagine that we wanted to create a lot of objects with different names and ages and jobs. So as we learned in the last lecture, we can use some kind of blueprint for this, right? So in JavaScript, there are a couple of different ways to create objects. But probably the most popular way is using something called a function constructor. And this is a very common JavaScript pattern. And the pattern is something like a standard way that we have to solve a problem always in the same way. So the function constructor is a pattern for like writing a blueprint, such as we have been talking before. So the name function constructor implies that we're going to use a function here, right? And we want this constructor to be called person. So we create a function called person, and the usual convention in JavaScript is that we always write function constructors with a capital letter here, right? So person is with a capital P, okay? And we always do this for function constructors. All right, so function and the parameters for this function constructors will be the variables that we want to set in our object. So in this case, it's going to be name, year of birth, and the job. And now I'm just going to show you how this is done, and I will explain to you why this works just in a second, okay? So what we do is to attach these variables, so these arguments, to the this variable of this function's execution context. So just like this. So this.name, and remember that the this variable is simply an object as well, so we can do it like this. So this name will be name, which means the one that we get here as an input for the function. So this dot name will be equal to name, which is the parameter of the function, and then the same thing for the other two. So this dot year of birth will be equal to year of birth, and then this dot job will be the job that we pass into the function. And that's it. This is the function constructor. And again, I will explain to you why this works in a second. Alright, and now that we have this function constructor in place, we can then use it to create a John object. So let's create some space here and then var John, we call new, and this is the new operator, new person, and then we pass our arguments into the function. So we already know our arguments, so 1990, and then the job teacher. So this is how we create new objects using the constructor function. And this is called instantiation, because these objects here are instances of the person object, as we learned in the last lecture. Alright, and as promised, I'm now going to explain you how all of this works. So first, in order to understand how this works, we need to first understand what the new operator does. So when we use the new operator, first a brand new empty object is created. Alright, so an empty object, this is important. Then after that, the constructor function, which in this case is person, right, is called with the arguments that we specified. Okay, so first an empty object is created, and then the function is called. So, and as we already know, calling a function creates a new execution context that also has a this variable, right? Now, we know that in a regular function call, the this variable points to the global object, right? But if we now look at our function constructor here, then having the this variable pointing at the global object wouldn't be so useful, right? Because like this, we would simply set all these properties on the global object. And that's of course not what we want. And that's why the new operator takes care of this. And it makes it so that the this variable of the function points to the empty object that was created in the beginning by the new operator. Remember that? So again, what the new operator does is to point to this variable, not to the global object, but to this new empty object that was created in the beginning when we used this operator. So then after that, when we set the name, year, and job properties to this, then that's the same as setting them right on our new empty object. Okay, and finally, if the constructor function does not return anything, and as you can see here, that is clearly the case, then the result is simply the object that was created in the first step. So this new empty object here. And this empty object, which was created here, now has the properties that we defined. So the name, year of birth, and job in this case. Okay? And then finally, all of this is simply assigned to the John variable. And just like this, we created an object called John simply by calling a function constructor. So again, our new operator here first creates an empty object, then it calls our function with the this variable not pointing to the global object, but to the new object that was created here. And then when this code here runs, the this variable is no longer the global variable. And so these are all set on the new object, which is then in the end assigned to this variable. So I hope that makes sense. So let's now add inheritance to the game. And for that, we are going to bring back our calculate age function. So let's now suppose that we wanted to add a method to our objects. And that sounds easy, right? We could just add it to our function constructor like we would do with a normal object. So just like this. So this dot calculate age, it's simply a function which logs to the console the age. So 2016, we already know this by now, minus this dot year of birth, right? And now we can actually use this, and it should, of course, work. So John.calculate age, and let's now open this. And that's not what I wanted, so here we are. And in a console, and what's this here? Oh, it's nothing special. So now it's all right. So 26 is our expected outcome here. So everything works just fine. So let's now create a couple of more objects here for more people. So var Jane is also a new person, and this is going to work the exact same way, right? So now I say Jane was born in 1969, let's say, and she's a designer. And it will also create Mark, so a new person called Mark, obviously. He was born in 1948 and he is retired. So if I now run this, then each of the object that is now created has the calculate age method attached to them, right? Because it's right here in the constructor function or the function constructor of all of these three objects, right? So again, each of these objects now has the method. Now in this case, it's just one function with one line of code. So this is no big deal. But now imagine that we had 20 functions in each object and that each of them would have 100 lines of code. Now that would not be very efficient, because then we would have 3 copies of the exact same thing, right? And that is exactly why we use inheritance in the exact same way that we have learned in the last lecture. So what exactly did we learn in the last lecture? So we've learned that we have to add all the methods and properties that we want to be inherited into the constructor's prototype property. And it sounds difficult, but it's really not. So let's just do this. Just creating some space here, and I will actually do it here. So all we have to do is to say person.prototype, because as I was saying, it's simply a property. So all we have to do is to use the dot and then prototype, and then we can add our function there. So calculate age and then our function. And I can actually copy it from here because it's the exact same code. Okay, and now I'm going to remove it from here. So right now, if I reload this, effectively none of the objects have the calculateAge method really attached to them, but still they are going to be able to use it. They will have access to it because it's in their prototype, right? So let's prove that. So I'm going to put all of these together and then call these methods on all of them. So calculateAge for Jane and also for Mark. calculateAge. And if I now reload this, here is the result. So all the 3 ages for all the 3 people. So again, the method is not anymore in the constructor, right? But we can still use it. And that's because it's in the prototype property of our function constructor. So inheritance actually works, and this is inheritance in practice. So this is really great, right? This is so powerful. You just really understood how this works and how it works behind the scenes. So you can not just use it, you can also understand why this works. And this is really extremely powerful and it's really great for you. So attaching methods to the constructor function's prototype property is something that is really common to use. We can of course also add properties instead of methods, but that's not really common, but I still want to show it to you, okay? So such as we did with the method here, we can do the same with properties. So once again, person.prototype, and now we can say, for example, a last name property. And we can say that they should all be called Smith, right? Because as we know, this will be inherited for all of them. And once again, I want to prove that to you. So let's console log this property. So first for John dot last name, and then for the other 2. So console.log Jane.lastName and then Mark.lastName. So let's see what happens. Okay, so all of them are called Smith. So once again, this property is not directly in the object, right? But we have access to it because it's in the prototype property of the function constructor. So all John, Jane, and Mark inherit this property. So once more, we proved that inheritance really works. And this is a really big deal. So if you understood this lecture and the last one, then you are well on your way to become a really great JavaScript developer. What I want you to do now is to create your own type of objects to play around with constructors and prototypes a bit. And this way you can consolidate what you just learned here. So I hope that sounds like a great idea for you. And then after that, let's go straight to the next lecture. The JavaScript console in our browsers is a very powerful tool to inspect objects and a prototype chain. So let's now quickly see how we can do that in practice. So I'm first going to show you how we can inspect the object that we just created in the last lecture right here in the console. Because the console is not just to log some stuff here into our console, like we've been doing, but also to do more powerful stuff, like inspecting objects. So let's first clear this, alright? And now we simply have to write the name of our object. So you see, this is a person object, and then our name, year of birth, and job. But now if we hit this little arrow here, then we get a lot of additional information about the object. Alright, so first here we can see all the properties that we added to this object. So the job, the name, and the year of birth that we associated to this very particular object. So everything is correct here, right? Now down here we have something called the proto. And this is in fact the prototype of the John object, which is, and I'm sure you remember this, the prototype property of the person constructor. So let's take a look at that. Okay, so here we have the calculateAge method that we added to our prototype here, right? So here we said person prototype calculateAge, and so we can see the calculateAge method here in the proto, which again is John's prototype, and therefore it's the prototype property of the person function constructor. And we also have the last name property that we also added. So let's also quickly take a look at person.prototype. Okay, and let's get some more space here for our console. So we see that this is in fact the exact same thing, right? This and this. Here it looks the exact same way. And just to prove you that John's prototype is in fact the prototype property of the person, I can actually do it like this. So proto, and then let's see what this comparison operator now is going to give us. Okay, true. So all this means is that in fact the prototype of John is the prototype property of the person function constructor. But I'm sure that you know this already by now. So let's go back to our John object here, and actually I'm going to clear this and write it again. Alright. So this is a proto. Now if we look at the prototype of John, we see that there's also a prototype here, right? So let's open that. And here we see that this is the prototype property of the object constructor. So as I said right in the first lecture about the prototype chain, all of the objects are actually instances of the object, right? So let me open this again. Okay, and so here we have a bunch of methods that are associated to the prototype property of the object function constructor. So again, this one here is the prototype property of the person function constructor, and this here is the prototype property of the object function constructor. And that's because the person function constructor is in fact an instance of the object function constructor, right? And that's why we can see this whole prototype chain here, right? So as I said, this console here is really useful to visualize this prototype chain and all of the prototypes that are in it. So as we already know, we have now access to these methods here, right? And that's right to our John object. So thanks to the prototype chain on John, we can use these exact methods that are here. And now I'm going to use the hasOwnProperty method just to show it to you, because it can be useful sometimes. So we can use this method to ask basically if an object has a property or not. So we can do John dot hasOwnProperty and then job, for example. And this is true because this object has a property called job, right? Now, if we try this with the last name property, then it's going to give us false. And that is because this is not John's own property. So this method only looks for own properties. This is a property that we inherited from the prototype. It's not really John's own property. And that's why this gives false. And this method can sometimes be quite useful. And now there's another operator that I want to show you. And this one is called instance of. So I'm going to say John instance of person. And this is also like a question because it will also give us true or false. And in this case, you can probably guess that it's going to give us true. So John is of course an instance of person because we created it through the person function constructor. And this one can also be useful sometimes. Okay, and with this we inspected our John object and the prototype chain that we just created. Now there's only one more thing that I want to show you, and that is to prove you again that almost everything is an object. So let me create an array here, just like this, just a very simple one. And let's now get some information about it. So if we just hit X, not a lot is going to happen. We cannot inspect this object right now. So we need to use console.info. And now we will be able to look inside of this object. And this is what we see. So we see the elements, and then we also see this length property here, right? And do you remember this length property? We use it all the time, for example, in our loops, right? And so now you know where this actually comes from. It used to look a bit like magic, right? But of course it's not. So it's always stored right here in this array instance. And that's why we can very simply use this property. So something like this. So x.length is 3, simply because this is stored right into this array object. Alright, and it gets even better, because down here we can also see the prototype of this array, which of course is the array function constructor. So this is another function constructor that is built right into JavaScript and allows us to simply build arrays. And here in its prototype property, we can see all of these methods that we have already used before, like pop and push here, right? Or we used unshift as well. So all these methods are right here in the prototype property of the array. And that's why we can use them. So did you never wonder why we could simply call the push method or something like this on all of our arrays? So now you know, it's because of the prototype chain. So all the arrays that we ever create will always have access to these methods because they are stored in their prototype. And that is how useful inheritance really is. So I hope things are really starting to make sense for you now. So let's now move on. In this lecture, we will talk about another way that we can create objects that inherit from a prototype, and that's the object.create method. So we have seen the function constructor pattern to create objects from a blueprint in the last 2 lectures. But there are more ways to create objects and inheritance. So let's talk about the object.create method now. And let's first comment out this code here. Okay. So this is object.create. All right. So with the object.create method, things work a bit different. In this case, we first define an object that will act as the prototype and then create a new object based on that very prototype. So let's do that right now. And we're going to recreate the person example that we used for the function constructor lecture. So first we have to write the prototype as a simple object. And I'm going to call it person proto. So person proto, and now you see we no longer use the capital P in the beginning because it's not a function constructor. And what I want in the prototype, such as before, is the calculate age method. So we already know why and how inheritance work. Now we're just doing it in a different way. Instead of using function constructors, we will do it the object.create way. So it's simply a different way. Alright, so calculate age and function. And again, I'm going to console log it 2016 minus this dot year of birth. Now there is no year of birth here anywhere, but we're going to take care of that later. Okay. And now let's create John again. So we simply say object.create, and then we simply pass it the object that we defined to be the prototype object, which will be person proto. Okay, so let's see this in the console. Alright, and I'm not gonna console log this, so I will just do it the way we did before in the last lecture. So John, and here is the object. And now it's empty, there's nothing here, right? But we still have the prototype, and this already has our calculate age function. So this looks a little bit like before, doesn't it? Now we just have to fill this John object here with our data. So we can simply do it the old way, right? So John.name is John. John.year of birth is 1990. And John.job is teacher. And if I reload this now and say John, then here we have our object. And it looks a lot like it did before with the function constructor, right? So we have our data here, the job name and year, and then the prototype, which contains our calculate age function. However, it was not ideal the way that we had to fill this here, right? So the object that we created was empty, and then we had to fill it here with the data. So this time we're going to do it a different way because the object.create accepts a second parameter. So let's now do that for another person. So Jane, object.create, and of course the prototype is again person proto, but then we can pass a second argument, which is an object specifying the data that we want to have in the object. So name, and now we cannot simply put the name here, but we have to do it in this rather strange way like this. So we have to say value, and then we can say Jane. Okay. So this looks a bit strange, but it's actually how it works. So there's no way around doing it like this. So year of birth, and then again value, and 1969, and then the job. And once again value, and then designer. Okay, and let's now reload this. And John again, and Jane. So both share the same prototype, as you can see here, because both have the calculate age method, and then they have both their own type of data in there. Okay, so let's think about this again. The difference between object.create and the function constructor pattern is that the object.create builds an object that inherits directly from the one that we passed into the first argument. While on the other hand, the function constructor, the newly created object inherits from the constructor's prototype property. Right? So that's the big difference. And I hope this makes sense to you. Actually, one of the biggest benefits of object.create is that it allows us to implement a really complex inheritance structures in an easier way than function constructors, because it allows us to directly specify which object should be a prototype. Alright, so function constructors and object.create will be the most common ways of creating objects that you will find the most when you're looking for tutorials on the web. And that's why I showed you both in this course. But the most popular though is still the function constructor. And so that's the one that I'm going to use mostly in the rest of this course.